What's up, everybody? This is me, Yawar Manzoor, and I believe everybody of you is doing great, nice, and absolutely fine. Come on, in the live chat, I need to know if everybody is doing great, nice. Okay. Okay. So, this is the one shot of kinematics. Today, we're gonna kill the entire kinematics in just one shot. This is not the revision type of one shot, it'll be a detailed one shot. Okay. So, it's gonna take more time than the normal one shot. Okay. So you have to basically stay over here for the entire time. So, and I'll be showing you approximately from 25 to 30 problems. Out of 25 problems, like 22 mostly are the previous year questions only. Okay. So all of you, come on, I need to know in the live chat, how many of you are feeling great? And is everybody excited about this one? And if you haven't subscribed this channel, subscribe it now. Hit the bell notification so that you'll get the update every single time whenever we come live. Okay, that's mandatory. That's mandatory. Okay. Yes. So this is a piece of information about me. You can definitely read it out from the screen. My name is Yawar Manzoor and I'm from Kashmir. And further moving over here, apart from this YouTube platform, we have our own platform. That's what we call the Unacademy's platform. Okay. And on this Unacademy, we have this basically plus, and you can basically take this iconic subscription. If you take this plus subscription, you're gonna get the benefits like live classes, weekly tests, structured courses, unlimited access. So these are all the benefits that you get in plus, understand? And country's top educators are teaching you over there. Unlimited access means you can watch anybody's lecture any damn time. Okay. So that's what we call the unlimited access, and in a particular category. And if you take this iconic subscription, you're gonna be getting all the benefits you get in plus, and there are some extra benefits as well that you get in this iconic. Like you get basically this personal guidance. What this personal guidance is all about, you'll be getting a personal mentor over there. He'll be helping you throughout your exam, how to crack the exam and all. And this test analysis is basically, once you give the test, one second. Yeah, okay. So once you give the test, afterwards you have to analyze basically in which portion you are lagging in which portion you have to work more. Okay. And this is the experts guidelines, study material, study planners, everything you're gonna get in over there. And this is basically my username on Unacademy. You can definitely follow me over there. That's Yawar Manzoor. And these are the batches we have recently launched on Unacademy. Like we have the Spark batch, and this is completely for 11th class, like JEE Mains in Advanced 2023. You can definitely enroll in this one in order to boost your rank for sure. Okay. Okay. So you should go for this Shine batch as well. If you are in class 12th right now and appearing for your JEE Mains in Advanced 2022, you should definitely enroll in this one, because this will help you in boosting your rank in the upcoming time. And this is how you can enroll in our special classes. Understand? Special classes are completely free. You don't have to pay anything. So you just have to sign up with your mobile number on Unacademy app, and then find me over there, search me, Yawar Manzoor. When you get my profile, this will be the interface. And in special classes, you can click all, you can watch any of my special class for free. So if you basically enter any of my lecture over there, it will basically ask you for a code. You can use my code, this Yawar in capitals, and you can watch any of my lectures. This is the IIT JEE Iconic Subscription offer, plus offer. And you can take this plus subscription for, like, you can take it for 3 months, you can take it for 6 months, you can take it for 12 months, 18 months, and 24 months. Okay. And if you take it for 12 months, it will be for this much of price. For this much of price will be 18 months, and this much of price will be for 24 months. Now, there are EMI options available over there as well. You can basically take, you can pay it monthly as well. There are so many options available over there, and you can use my code in order to get the maximum possible discount. This is my code, and this is my code on Unacademy. You can take definitely this iconic subscription as well, iconic subscription as well, iconic subscription as well. You can take it for 12 months, 18 months, 24 months. By using my code, you can get the maximum possible discount for sure. Okay. Okay. So use my code for getting the maximum possible discount. And this is the IIT JEE Mega Combat Scholarship Test. This happens every Sundays. You can win up to 4 crore rupees scholarship for sure if you enroll in this one. Okay. Now, previously it was on 22 of August. Now it will be on 29 of August, 11 a.m. There will be 21 questions. You have to solve those in 60 minutes. And next we have, if you find any of my content as inappropriate, you can definitely report over there. Okay, the link will be in the description below basically. Yeah, good evening. Okay, everybody is excited, so shall we start? We're gonna kill all the questions from kinematics today, and every topic. This is a detailed version of kinematics. Definitely, and that too completely in English language. So let's basically start from entirely basics. Okay, if anybody is having the doubts from the basics itself, then he is welcome. Okay, now let me just start. So first of all, we talk about this mechanics. What this mechanics is all about. Mechanics is nothing but study of motion. Now, what is the study of motion? If I say, for example, there is a car, okay, it's coming towards me. I have a question in my mind that how much time it's gonna take to reach from that point to this point. What is the velocity of this car? What is the acceleration of this car? Is there any force that is acting on this car? Or I'm throwing this ball, that ball is basically rolling on a surface. I'm saying that the ball will basically stop after some time. Why is it stopping? Is there any sort of force that is pulling it in backward direction? That's why it stops. So all of these questions are come under the mechanics, understand? So whenever the body is in motion, whenever we study that motion, what is its acceleration, velocity, how much time it's gonna take from this point to this point, what will be its velocity after some time, this all comes under mechanics. These all questions come under mechanics. So this is what we call the oldest branch of physics. This is the very old branch of physics. Okay, so in this branch we talk about the mechanics, we talk about the study of motion entirely. Now it has further 3 branches. The first one is classical mechanics, quantum mechanics, and relativistic mechanics. Now if I say, for example, there is a body which is having finite size, like there is a car that's coming towards me. Okay, so this is having the finite size, it is having finite velocity. So if we study the motion of this body, it comes under the classical mechanics. So there are laws of classical mechanics that are applied on these bodies. Then comes the quantum mechanics, when we have a particles which are having very small size, understand, 10 raised power minus less than that, understand. In that case, we study the motion of those particles, electrons, atoms, and those. We study the motion of those particles under the quantum mechanics, understand. We cannot use the laws of this over here. So that's why there is a separate branch for this. This is the separate branch for this. Now if a body is moving with the speed of light, in that case we are studying, if we want to study the motion of that body, that comes under the relativistic mechanics. So these are basically the 3 branches. Then comes the further, that is kinematics and dynamics and statics. Okay, so what is this kinematics, dynamics, and statics? See, in our syllabus, class 11 syllabus, we have to basically deal with classical mechanics only. So in this classical mechanics, there are further sub branches. The first one is what we call the kinematics. The second one is what we call the dynamics. The third one is what we call the statics. In this kinematics, see what we are going to see. If I say, for example, there is a body, okay, this is a car that's moving in the forward direction, okay? This car is moving in the forward direction. If I ask you how much is its velocity, how much is its acceleration, how much is much is its speed. Okay, so when we talk about this stuff, how much displacement it has covered, means we are talking about the kinematics of this body. We basically see in kinematics what are the changes that happen to this body. Now in dynamics, what comes under that? That is force. When we say, if I say, for example, I applied some sort of force on this one, it is stopping because of some force. So this stuff comes under the dynamics. That's why in dynamics, we'll be talking about the forces only. Over here in kinematics, you will see only velocity, acceleration, displacement, this stuff only. And the statics we'll be studying in the engineering. If there is a, for example, big bridge, okay, and the big truck is moving on this one, still the bridge is not breaking. Why? Because there are some laws of statics. So it is holding, it's balancing the force. So this all comes under statics. We don't have to deal with that. So right now, kinematics and dynamics in detail, okay? Fine. Now we have this kinematics. In this kinematics, first of all, we need to talk about this rest. We need to talk about this motion. If I say, for example, this is a car over here, okay? These are some of the basic concepts that you should know in order to study the concept. It will take mostly 2 hours, okay? We'll try to finish this in 2 hours. And we'll have like 25 to 30 questions. We have to solve all of those in this lecture. And do let me know if you get any sort of confusion anywhere. Do let me know at that point of time only. Okay. Now, if I say, for example, this is a bus over here. This is moving in the forward direction. Now, there is a person sitting inside this bus. I call this as A. I have given this example previously, in the lectures also. So, this is a person over here. This is B inside this bus. Now, there is the person C over here. If I say this person, tell me one thing, is this person A at rest or this is in motion? This C is clearly saying that the bus is moving in the forward direction. So according to me, this A is in motion. So according to C, this A is in motion. Now I told this B, is A in motion or rest? B is saying the A person is exactly sitting on my side. I can basically talk to him. I can share anything I want with him. So according to me, A is at rest. So who is basically correct over here? Both are correct. Understand? So in simple, we say if any person is at rest, he is not basically changing his position. He is not moving. He's at rest. That's okay. In motion, the body is in motion. We say that is in motion. Now in detail, what exactly the concept? Let me just make you understand that. So we say this person is at rest according to, this person A is at rest according to this person B. And this person A is in motion according to this person C. Means when we take this as a frame of reference, that means in that case, this is in motion. When we take this as a frame of reference, that means this is at rest. It completely depends upon the frame of reference. Understand? So that's why frame of reference can be anything. It completely depends upon you. So previously the question was incomplete when I asked you, is this at rest or is this in motion? So I had to ask you at that point of time, according to what, with what reference frame this body is in rest or motion. Now when I say according to this, then the question is complete. According to this, this is in motion. According to this B, A is exactly at rest. Both are equally correct. Okay, fine. I hope you got the feel of this and this. That's why we say rest and motion are relative. Now, we have this translational motion. What is translation motion? A car is moving in like on a straight road. This is a translation motion. Car is moving like this in a curve. That's also a kind of translation motion. Let me just make you understand. So we say this translation motion is of 2 types. That's rectilinear motion. That's curvilinear motion. Okay. What is rectilinear motion? If, for example, the road is straight, in that case, the car is moving on a straight road. In that case, we say the motion of a body as rectilinear translational motion. Understand? In this, the line, in this rectilinear motion, if we basically define it from the physics point of view, the body will basically be the line joining the 2 points. If we take basically any 2 points, it will be parallel to itself throughout the motion. Over here, it will be parallel to this one throughout the motion. It is basically in case of translational motion. So what is the condition for translation motion? The line has to remain parallel to itself throughout the motion. The line has to remain parallel to itself throughout the motion. Understand? Now, what is the rectilinear translation motion? When the road is completely straight, in that case, we say that is rectilinear motion, rectilinear translation motion. Now, what is curvilinear translation motion? When the road is curved, in that case, we say that is curvilinear translation motion. But what is the condition for translation motion? The line has to remain parallel to itself. If a car is, for example, moving like this, if a body is moving like this, so this is body. I'm taking the 2 points over here. I'm taking the 2 points over here. Over here, I'm taking the 2 points. So this is a curvilinear translation motion. Okay. So in this case, is the line parallel to itself? 100%. So over here, over here, over here. Okay. It is like this. It's like this only. Okay. So the line is parallel to itself. The line is parallel to itself. We say basically this is curvilinear translation motion. Why? Because the road is curved. Fine. Then we have this rectilinear motion. We call it the one-dimensional motion. And this we have two-dimensional motion and three-dimensional motion also. Now, let me just tell you what is one-dimensional motion. If only one of the coordinates of a body are changing, we say the motion is called the one-dimensional motion. In this case, if a car is moving in the forward direction, how many coordinates are changing? If I make the coordinate system over here, only x is changing. Okay, if for example the car reaches over here, at here x is 0, here x is 1, here x is 2. Understand how many coordinates are changing? Only one coordinate is changing. We say this is one-dimensional motion. Now see, at this point, for example, how much is y? You say y is 1. Over there, how y is still 1, y is still 1. So y is not changing, no other coordinate is changing. We say only one of its coordinates are changing. That's why this is one-dimensional motion. Now the point comes, when we release this motion under gravity, free fall, is this one-dimensional motion or two-dimensional motion? This is also the example of one-dimensional motion. Why? Because in this case, only y coordinate is changing, x is same. Now see, when the ball is exactly at this point, I say x is, for example, y is, for example, 10. When it reaches this point, y is 5. Over here, y is 0. Understand? So y keeps on changing in this one. Only one of its coordinates are changing. Among 3 coordinates, only one of its coordinates are changing. Now, what about its x? At this point, if I say x is, for example, 10, so means when the body was here, x is only 10. If it moves in the forward direction also, then its x will also change. But over here, it's under free fall. So we say this is also the example of one-dimensional motion. So what is two-dimensional motion? In which two of the coordinates of a body changing, that is projectile motion. Understand? Circular motion. Okay, in this x, you are changing x as well as y. Understand? Three-dimensional motion. What is three-dimensional motion? We say the example of a plane. Understand? That is the three-dimensional motion. Moving, or a kite. Example of a kite. Understand? I'm fine, you say. Now comes the concept, that is a distance and a displacement. Let's move on to the distance and displacement. It will end like in next 2 lectures, okay? Chill. No need to worry about anything. One-dimensional motion only. One-dimensional motion only. Until and unless if the two of the coordinates of a body are changing, we say that is two-dimensional motion, okay? Yeah. Okay? Now, see, distance and displacement. What is distance and what is displacement? You say actual path. Let me just give you the feel. If I say, for example, I am living over here. This is the place A. This is my house, okay? And my friend lives over here. This is the point B. There are so many roads from point A to point B. First one, second one, third one, fourth one, fifth one. Okay, these are the roads. Okay, now if I ask you, I'm going through a road number 1, then with road number 2, 3, 4, 5. Okay, so I traveled through all of these roads. Understand? First, second, third, fourth, fifth. When I'm traveling through road A, I'm saying I'm covering the distance. It's simple. I'm traveling to somewhere means I'm covering some distance. Understand? Now, when I'm going through road 2, I'm also covering the distance. When I'm going through road 3, I'm also covering the distance. For instance, you assume this, obviously I'm covering the distance. When I'm going through road 4, I'm covering the distance. I'm covering the distance through road 5. I'm changing my distance, covering my distance, this much of distance, fine. Now the point over here is, when I'm going through this road 3 from A point to B point, in that case, I'm covering some special type of distance. Understand? Why is this special? See, all of these are normal distance, but this is special type of distance. Why is this special type of distance? Because this is having a proper direction, a unique direction. Understand? Depends upon initial point and final point. How? See, you take this point A, initial point, you take the final point, and you just close your eyes and basically take a line from A point to B point. You can definitely make it. That's why it depends upon initial point and final point. And if you go through this, it is having different directions at different points. At over, it's like this, it's like this, it's like this. So, but over here, from this point to this point, it's having a unique direction pointing towards the B. So that's why this is a special type of distance. This is also a distance, but special type of distance. Now the point over here is, can we say this is the shortest path among all of these paths? 100% this is the shortest path. Understand? So this special type of distance, what we call the displacement. Understand? So all of these are distances. Distances are all, but this is a special type of distance. Why? It's having a particular direction. Shortest path depends upon initial point and final point. Now if you ask me, sir, if I have traveled through this one path only, in that case, what is distance and what is displacement? In that case also, this is the displacement. Understand? Displacement is basically how much you have displaced from your original point. So in this case, how much you have displaced? Only this much or this much? No. If you are traveling through any path, but at the end we have to check, we have to see, yeah, we have to see how much you had displaced from your original position. Understand? So this is basically the scene over here. This is the actual path. We say this is the actual path traveled. If you travel through this path, for example, if I say you are traveling through this point to this point through this path, okay, I'm asking you, tell me the displacement. You will say displacement can be that special distance, that path, which is the shortest one, which is the having the proper direction. So that is this one only, that is this one only, that is this one only. Okay, fine. So we say displacement can be zero also. Displacement can be zero also. How? Displacement means how much you have displaced from your initial position. Okay, fine. Yeah, these are those slides only. Okay. Yeah. Why do you ask like that, bro? Okay. I'll tell you everything. Don't worry about that. Okay. The people who have already studied this, then it's more fine. Okay. This will be the revision for those people. Okay. The people who haven't studied it, that's why I'm going in a bit detail so that you'll be able to understand this more properly. Does it really matter? Do I have to get the new slides or you want the content? Okay. So we said displacement can be zero. We said displacement can be negative also. Displacement can be positive also. Understand? Means a displacement positive means from the origin where you are standing exactly. If this is the origin, if you are over here, where, if this is the origin, oh, I'll tell you everything about this later. Chill scenes. Right now we'll study. Okay. So for example, if I say, for example, this is the origin from where I am measuring the displacement and I'm standing over here on the left of, for example, minus 10 meters. In that case, I would say displacement is negative. Never say if the body is moving in the left direction, you will say displacement is negative. No, this is completely wrong. If the body is moving in left direction, velocity is a negative at that point of time. If body is moving in right direction, we say velocity is positive. But if the displacement is negative, means where are you standing? How much you have displaced in the left direction, where you are standing from the left of the origin. And if displacement is positive, means where you are standing on the right of the origin. Okay. Keep these things in your mind. Now, this is a question over here. I want you people to answer this question. There are so many new questions that you will face today. Okay, I told you there are the questions which are like previous. Most of the questions are previous year questions only. Okay, you will love all of those. You tell me one thing. This is just the basics. We are starting. Okay, we just started kinematics. You tell me one thing. In this case, a car started initially. Okay, from the, I would say from your house, from your garage, started initially in the morning and it covered, for example, its initial reading was 5,000 kilometers. So when you reached back home, its reading was, that reading speedometer was showing 6,200 kilometers. You tell me in this case, how much is the displacement? How much is the distance? Come on, everybody in the live chat as soon as possible. We have to kill lots and lots of questions. Okay. Come on, everybody. I want you people to tell me how much is the displacement over here, how much is the distance over here. Come on, we don't have that much of time, okay? Don't think too much. Come on, answer me these questions as soon as possible. Come on. Can you tell me? Distance is a 1200. Somebody is saying 600. Come on. Displacement as well as distance. In the live chat as soon as possible. I need to know. Okay. See, if I'm traveling from my home, for example, if I started my car initially from my home and I traveled, initial reading was 5,000. Finally, my car reading is 6,200 kilometers. But the final point is same. I parked the car in the same garage. So can I say my displacement is zero? Why? Because my car hasn't displaced. Understand? That's why. And what about the distance? How much it has covered throughout the day? That is 6,200 minus 5,000. That is 1,200 only. That is 1,200 kilometers. Understand, everybody? Displacement is zero over here. Okay. Your voice is low. No. You are having some problem, bro. Everything is fine, huh? Everything is fine. Okay, so now you tell me one thing. If I travel from A point to this point, then to this point, so how much is the displacement over here and distance over here? Can I say, and again I reach the same point A, same point A. That's why I told you displacement is basically how much you have displaced, how much you have displaced from your original point. In this case, you are reaching the point A once again. So I would say displacement is basically 0, and distance is how much? Distance is nothing but 18. Why 18? Because 4 plus 3 plus 2, that is 9. And once again 4 plus 3 plus 2, 9, because you are reaching A point once again. So can I say it like this? Yeah. Now let's move on to the speed. Let's move on to the speed. Okay, let me just give you the feel of speed, what exactly speed is. Everything is still the same, bro. Can you, the other people over here, can you tell me, is the voice clear? Am I audible properly? Come on, all of you. I just need to know as soon as possible, because I'll have to fix this accordingly. Royal is saying crystal clear. Okay, I'll just increase my my own volume. Don't worry about that. Chill. Okay, let me just tell you. See, right now, okay, this is the speed. We need to focus on speed. Now, what is speed? If somebody is moving, we say it's having some speed. Okay, that only. Let's understand the speed from the physics point of view. If you are traveling from this point A to this point B, okay, I'm asking you how much you have how much distance you have covered. For example, same previous example, 100 kilometers. Okay, and how much time you took from A point to B point? You say 5 hours, sir. Okay, I'm asking you from A point to B point in general, how much is the change in distance? You say my change in distance is nothing but that is 100 minus 0. Simply na. Or you will say d2 minus d1, or you will say delta d by delta t. Change in distance upon change in time. Very simple. So that is 100 minus 0 upon 5 minus 0. Can I simply say it like that? So that will come out to be 20 kilometer per hour. Listen to me very carefully. This is a practical example. I'll make you understand what exactly speed is. Okay, from A point to B point, for example, if you have covered 100 kilometers in how much amount of time? 5 hours. Okay, fine. I'm saying you, how much is the change in distance from A to B? You'll say 100. How much is the change in time? You'll say 5 hours. So if I divide this with this one, it will come out to be 20 kilometer per hour. So what is this 20 kilometer per hour? What information this 20 kilometer per hour is giving you? This is saying that every hour you are covering the 20 kilometers. Every hour you are covering the 20 kilometers. If I say, for example, this is 100 kilometer per hour, means more speed you have, means every hour you are covering the 100 kilometers. How fast you are changing the distance. Understand, from A to B, how fast you are changing the distance. Over here, you are not changing the distance very fastly, because only 20 kilometer per hour. Here, 100 kilometer per hour. So this change in distance, with what rate you are changing the distance, how fast you are changing the distance. More fastly you are changing the distance, more speed you have. Less fastly you are changing the distance, less speed you have. So this is what we call the rate of change. Rate of change. Understand, this rate of change is a golden concept. So rate of change. What is this rate of change? This rate of change. What rate of change of what? Rate of change of distance with time. With what rate you are changing the distance? So over here, with 20 kilometer per hour, 100 kilometer per hour. So this rate of change of distance is nothing but, after some time, for decades we were saying this rate of change of, what is your rate of change of distance? My rate of change of distance is, that is 20 kilometer per hour with time, 30 kilometer per hour with time. But after decades, we give it a beautiful name. That's what we call the speed. Understand, what is speed now? Rate of change of distance with time. With what rate you are changing the distance? Like from A to B over here, with what rate you are changing the distance? 20 kilometer per hour. Every hour you are covering the 20 kilometer per hour. Now if I say your rate of change of distance is 100 kilometer per hour, that means you are moving very fastly in that case. Everybody understood this? Come on, in the live chat, drop a Thumbs up if you understood this one. Come on, come on. Come on, come on, in the live chat. Okay. In the live chat, I need to know. Later on, we'll talk about this stuff, whatever you are saying, okay? Okay, so can I say basically this is nothing but what is speed? Rate of change of distance with time. With what rate distance is changing with time? Now, can I say over here, this speed is a nothing but, in this case, I'm saying you in general from A to B, what is your rate of change of distance with time? That is, can I say this is nothing but, it is nothing but average speed, average rate of change, average rate of change. 100% I can say this is average rate of change, because in general you told me from A to B with what rate you are changing the distance. Understand? Fine. Now let me just tell you, see, you are telling me in general A to B what is my rate of change or what is my speed. If I ask you to tell me at any particular point what is my speed, you will say that simply that is nothing but SINS, instantaneous speed. How do you represent that? That is ds by dt. dd by dt, you write distance, change in distance at that particular point. You say average rate of change is nothing but from A point to B point with what rate you are changing the distance. But at any particular point, if I ask you, you will say at that particular point with what rate at that particular point distance is changing with time. How fastly the distance is changing at this particular point, that is the instantaneous speed. Okay, we represent it like this. Let's move on to the another one. Everybody, come on. Okay, okay, fine. Let's talk about the velocity now. Let's talk about the velocity now. Come on. So what is velocity? Now let me just give you the feel. Velocity is, we will have, it's a vector, it's having direction. Now say if this is a car, okay, this is moving in the left direction with a speed of, I would say, 40 kilometer per hour, okay, and the same car, the another car is moving in this direction with same speed, 40 kilometer per hour. In this case, could you please tell me what is same as what is different? In this case, can I say speed of A is nothing but speed of B? 100%. This is moving with a 40 kilometer per hour. This is moving with a 40 kilometer per hour. But what is difference? What is basically different over here? That is velocity. Velocity of A is not equal to velocity of B. This is having the same speed, but in this direction. This is having the same speed, but in this direction, the opposite direction. That's why velocity is different. Whenever we talk about velocity, means we are talking about a magnitude of speed plus direction as well. If I tell you, for example, this car is moving in this direction with 40 kilometer per hour towards right. Okay, that means in this case, I am talking about its velocity. Understand? When I am basically saying that it is having a specific direction, when I'm mentioning the direction as well, that means it is having this velocity. When I say only 40 kilometer per hour, that means it is speed. That's why the speedometer tells you the speed only. When you are sitting inside the car, just look at the speedometer. That will give you the information with what rate you are changing the distance, how fast you are going. It will not tell you in which direction you are going. So for that, you have to look outside in which direction you are going. Understand? That's why we call that speedometer, not a velocity meter. Fine. Chill scenes. Now, we said this velocity is how this velocity will come. See, let me give you the feel of this one, man. Okay, okay. See, I'm saying you the simple question, that is, you told me in previous case, when you were traveling from A point to B point exactly, from A point to B point exactly, in that case, you told me rate of change of distance with time from A point to B point. Fine. Now I'm asking you, if you are traveling from A point to B point, this path, through this path, I'm asking you to tell me that speed which is having a proper direction, which is having a uniform direction, understand, which is having a proper direction. You will say that is a special type of speed, like we previously discussed in case of distance and displacement. So that special type of speed will come with special type of distance. Understand? See, you basically told me when we were defining the speed, in that case you will say change in displacement, change in distance upon change in time. But when I'm asking you what will be the formula for velocity, you will say change in special type of distance upon change in time, because that special type of distance will give you the what? That will give you the direction. That special type of distance is nothing but displacement. So can I say from A to B, velocity is nothing but delta S by delta T. What is S? That is a displacement. Displacement is the only quantity that will give you from A point to B point a particular direction. Understand? So this is nothing but average velocity. We say from A point to B point, delta represents average. Now, if I ask you to tell me the instantaneous velocity at any particular point, a speed which is having with a direction as well. So you will say VINS is nothing but ds by dt. Any confusion in both of these? Come on. In the live chat, any confusion? Come on, write CC in the live chat, crystal clear. Then we'll have to move forward. Okay? Then we'll have to move forward. I'll have to show you lots and lots of questions by today itself. Everybody. Okay, that's great. Fine. Now, if I have a question over here, I'm asking you the simple question. Tell me if the displacement, if this is a car, okay, this is traveling in the forward direction. It's a displacement time relation is given. Displacement is changing with time, means at any time it will have some displacement. So in that case, you tell me average velocity from 0 to 2 and instantaneous velocity at t is equal to 5 seconds. Come on, can you solve this? Can you solve this in a very less amount of time with the speed of light? Come on, tell me over here how we are supposed to find the average velocity. Can we just write VAVG is the nothing but, how do we find the average velocity? That is change in displacement upon change in time, or total displacement traveled upon total time taken. So how do we represent that? Delta S by delta T, or we say it final displacement minus initial displacement, that is S2 minus S1 upon T2 minus T1. Do we write it like this exactly? Now what is this S2? S2 is nothing but when time is T, when time is 2, because we are supposed to find it from 0 to 2 seconds. It is something like this. Car is traveling from A point to B point. Understand? A point to B. Over here time is 0, over here time is 2 seconds. That's why. How do you find this S2? You will simply say S2 is nothing but when you put the value of 2 over here, that is 2 into 2 plus 4 into 2. How much this is? 2 square exactly. Instead of this T, you will put what? 2, because you are supposed to find S2 displacement when you are at T is equal to 2 seconds. How much displacement is there? How much you have displaced? Come on, everybody, do let me know what is the answer of this one. Yeah, 8 meter per second and 24 meter per second. Everybody. So can I say this is nothing but, this is 4, 8 and this will be 16. So S2 is basically 16. S1 is nothing but 0. Why 0? Because if you put T is equal to 0 over here, S1 will become 0. So it's 16 minus 0 upon T2 minus T1, that is 2 minus 0. We say 8 meter per second is basically average velocity. So VINS is nothing but, what is rate, what is instantaneous velocity? That is how we differentiate this one, because that is ds by dt. Told you previously, what is this ds? At any particular point, with what rate you are changing the displacement. Understand? Average is from this point to this point, what is your velocity in general? Fine. At any point, what is your velocity? That means at this point, how fast you are changing the displacement. This is the feel. From this point to this point, with what rate you are changing the displacement in general, from this point to this point, that's okay. But at this point, if I ask you what is your velocity, you will say, means how fast I am changing the displacement at this particular point, that is my velocity at that point. So if I'm changing very fastly at this particular point, means I have more velocity. So that's why ds by dt. So what is the differentiation of this one? That is 4t plus 4. Differentiation, I know you, I hope you know how to differentiate this one. So 4 into 4. So how much that will be? 4 at 5 seconds. 4 into 5 plus 4. How much that is? 24 meter per second. Come on. In the next question, very simple question. You are supposed to solve this one. V is equal to 60 square plus t. Okay. You need to find the displacement in this case. Previously, what was given? Displacement time relation was given. You were supposed to find average velocity. Now velocity is given. You are supposed to find displacement. In this case, you will do the reverse process. See, we say V is equal to ds by dt. Understand? Take this over there. So you will get ds is equal to v dt. Now, what you are supposed to do over here, I'm asking you to integrate. I'll give you the feel of this one. Why do we do this stuff after some time? So ds, integration of VDT, integration of ds. When you add small ds's, you will get total displacement. So you'll get total displacement. Integration of VDT from where to where? 0 to 2 seconds. From 0 to 2, it'll be 6t square plus t. If you integrate it, means if displacement is given and you are supposed to find the velocity, what you gonna do? You will differentiate, like in the previous case. You will differentiate. Now, if a velocity is given, you are supposed to find the displacement, the reverse process. You will integrate. So integrate this one, find the value, and then put the limits from 0 to 2, because you are supposed to find the displacement from 0 to 2. You will get the value of displacement. Moving on to the next question. This was asked in the recent JEE Mains 2021 March or July shift. Okay, recent question. Come on, answer me this question as soon as possible. I'm waiting for you people. Which option is correct? A, B, C, D. On the same concepts, okay? No rocket science, no other concept, okay? On the same concept. Come on. The instantaneous velocity of a particle moving in straight line is given as this one. Understand? Where this is alpha, where alpha and beta are constants. The distance traveled by the particle between 1 second and 2 seconds is, I told you, when you are supposed to find the displacement from velocity, you are supposed to integrate. Do the integration and tell me the answer. Come on, I'm waiting for you people as soon as possible. Come on. Which option is correct among all of these? Tomorrow will be the one shot for calculus, okay, in detail. Now, see, solution. We say velocity is nothing but ds by dt. Fine, take it over there. So it will be ds is equal to vdt. Okay, now if we want to find displacement from velocity, we'll integrate. So integrate it. Understand? Integrate it. Integration of ds, it will give you the total displacement from 1 to 2 if you are supposed to find. Okay, so it is s. So it will be integration of from 1 to 2 exactly. And what is the relation? What is the velocity relation? V is equal to alpha t plus beta t square and it is nothing but dt. Bus, that's all. You need to integrate this, find the answer. So what will be the integration of this one? So can I just write it? I'll just write it over here only. So s will be nothing but integration of, with respect to t we are doing it. So can I just write alpha t square by 2 and this will be plus beta t cube by 3 and from exactly 1 to 2. Now put the limits. So this will be alpha by 2 instead of t first we'll put 2 square minus 1 square, then plus we'll put beta by 3, we'll put 2 cube minus 1 cube exactly. So this s will come out to be, so this will be nothing but 2 cube 2 square, that is 4 minus 1, that is 3. So this will be 3 alpha by 2 plus 7 beta by 3. Which option is correct? Option A is the correct one. Hey man, let's first finish this one. Afterwards, we'll talk about the other chapters as well. Okay. Now, tell me what is the answer of this question. Average velocity. From this point to this point, I'm asking you to tell me the average velocity. See, the first half of this distance is covered with velocity v1. The second half is covered with velocity v2. A car is traveling from this point to this point. First half is covered with v1. Second half is covered with v2. You are supposed to tell me what is the average velocity in this case. A lot of people will say v2 plus v1, v1 plus v2 by 2. No, this is not the arithmetic mean that you are supposed to do. What you are supposed to do over here is VAVG is nothing but total displacement traveled upon total time taken. How much is total displacement traveled? Can I say, or this is S2 plus S1 plus S2 upon T1 plus T2 exactly. Can I say it like that also? Tell me, How much is S1 plus S2? This is x plus x, means total displacement traveled. That's 2x. Now, what is T1? Can you find the T1? That is, T1 is the time taken from this point to this point in covering the first half. That is x by V1. T2 is nothing but x by V2. Put it over here, solve the question. So that is x by V1 plus x by V2. This will get cancelled off. So it will become multiply, cross multiply over here. This will be V1 plus V2. So it will be V1 plus V2, and this in divide V1 V2, take it over there, it will be V1 V2. So which option? Option D is correct, not this one. Come on. Yeah, exactly. Let's move on to the acceleration now. Let's move on to the acceleration. Now, see, if I say I'm traveling from A point to B point, understand? My velocity is changing from A point to B point, not a constant. Velocity is not a constant. Okay? Means, what is acceleration in real life? When you basically press the accelerator, you'll basically feel some sort of push. That push is you are accelerating. Understand? Whenever there is change in velocity, you will say there is acceleration. If velocity is constant, there is no acceleration. Understand? If even the body is speeding up, means there is acceleration. If even the body is speeding down, means there is acceleration. So if velocity is not constant, from here to here, velocity is changing 30 meter per second, 40 meter per second, 50 meter per second. Okay? 40 meter per second, 50 meter per second, 60 meter per second, 70 meter per second. So in that case, I would say from this point to this point, velocity is changing. Now I'll ask you the simple question. What is that? With what rate is the velocity changing from this point to this point? Tell me. Like in previously, when you were traveling from A point to B point, with what rate you were changing the displacement from A point to B point? You will say, you said delta S by delta T. That was the change in displacement upon change in time. Tell me in this case, from A point to B point, with what rate you are changing the velocity, or what is change in velocity or upon change in time? You'll simply say that is nothing but over here if I say V2, over here if I say V1, T2, T1, okay? When time is T2, velocity is V2. When time is T1, velocity is V1. Tell me how much is the change in velocity. You'll say it is nothing but delta V upon delta T. Can I say it like this? 100%. Now this delta V by delta T is nothing but average rate of change. Okay? Average rate of change of what? Velocity. So for decades, we were saying that this is nothing but rate of change of velocity with time. Bro, what is your rate of change of velocity with time? What is your rate of change of velocity with time? So we were saying like, finally physicists came, they gave it a beautiful name, that is acceleration. So how much is your acceleration? How much is your acceleration? What is that? With what rate you are changing the velocity? Change in velocity from A to B. So we call this as average acceleration, because in general you are asking me from A point to B point, what is your change in velocity upon change in time? Understand? With what rate you are changing? Everybody understood? Come on, drop a thumbs up in the live chat. Yeah, I know Kashmir Institute of Excellence. Come on, in the live chat, I need to know. You understood this one, average acceleration? Understand? Now, if I ask you the simple question at any particular point, tell me with what rate you are changing that velocity at any particular point. In that case, you will say, previously you said from A point to B point, average velocity was delta V by delta T. At any particular point, instantaneous velocity was ds by dt. In this case, can I say at any particular point, acceleration is nothing but dv by dt? AINS, 100%. So this is giving me the information at any particular point with what rate you are changing the velocity, how fast you are changing the velocity at any particular point. Fine, everybody understood this one. We say acceleration average is nothing but delta V by delta T. In general, from A point to B point, with what rate you are changing the velocity at any particular point, with what rate you are changing the velocity, that is nothing but instantaneous acceleration. We say acceleration is nothing but meter per second square. Its unit is meter per second square. Yeah, what is that, man? It is nothing but it is meter per second per second. Okay, what is meter per second per second? Let me just give you the feel. I told you that 40 meter per second. Velocity is 40 meter per second. It means every second you are changing, you are covering how much of displacement? 40 meters. Every second 40 meters. Every second 40 meters. Fine. If I say 20 meter per second, it means every second you are covering 20 meters. Every second you are covering 20 meters. Every second you are changing 20 meters. Fine. Now if I say that is 20 meter per second per second. This is acceleration. 20 meter per second per second. What does this? Means every second you are changing the velocity by 20 meter per second. Every second you are changing the velocity by 20 meter per second. When there is change in velocity, there is acceleration. How many of you people understood the unit of acceleration? You got the feel, you got the goosebumps. Come on. If I say 40 meter per second, it means every second you are changing 40 meter per second. Understand? So this is the feel of unit of acceleration. With what rate you are changing the acceleration? This is also explaining us that. Shall I move forward? There are some special cases that we need to discuss in this acceleration. Okay. Once we get done with this, then we'll have to move on to some problems. Now, special case is basically case number 1. Is it possible? Okay, is it possible, ladies and gentlemen, velocity is increasing, acceleration is decreasing? A lot of people say that, sir, velocity increasing, acceleration decreasing. It is not possible. Velocity increasing means body is accelerating. There has to be acceleration also that is increasing. Let me just give you the feel. Okay. If the car is traveling from this point to this point, okay, the velocity, what is happening with the velocity? 200, 230, 250, 260, 265, 265. In this case, velocity is increasing. What is happening with the acceleration? Acceleration is what? Change in velocity. Tell me how much is the change in velocity? 230 minus 200, that is 30. 250 minus 230, that is how much? That is 20. 260 minus, this is 10, this is 5, this is 0. So, velocity is increasing. What is happening with the acceleration? Decreasing. 30, 20. Hey, change in velocity is nothing but acceleration, man. So 30, 20, 10, 5, this 0. Understand? Everybody, that deceleration is something else. I'll give you the feel of that also, okay? It's a positive acceleration over here, okay? Fine. Velocity is a decreasing, acceleration is increasing. I have told you these points in detail in L1, L2, L3, okay? Now, velocity is decreasing, acceleration is increasing. In this case, tell me what is happening with the velocity. You'll say 250, 200, 150, 90, 0. This is when we applied some brakes, okay? In this case, what is happening with the velocity? That is what? Velocity is decreasing. What's happening with the acceleration? 150 minus 200, that's 50. Over here, it is 60. Over here, it is 90. So, acceleration is increasing. Acceleration is increasing. Now, case number 3, velocity is maximum, acceleration is 0. Is it possible? See, from 0, 200, 230, 250, 265, 265, 265. Now, from this point to this point, velocity is increasing, okay? Now, could you please tell me what is happening with the acceleration? Over here, acceleration is 30, 20, 10, 5, 0. Means when velocity is maximum 265, you are running with a velocity of 265. 265. In that case, in that interval, acceleration is 0. Why is acceleration 0? Because over there is no change in velocity. Now you are moving with 265 constant. 265. I told you when velocity is constant, acceleration is 0. When there is change in velocity, there is acceleration. That's why this case is telling you velocity is maximum, acceleration is 0. Moving on to 4. Acceleration is maximum, velocity is 0. Just the reverse, okay? In this case, velocity, this is happening with the velocity. 200, car is moving. 200 is velocity, then 150, then 90, then 0. Understand? So what is happening with the velocity? Decreasing, decreasing, decreasing. Understand? In this case, over here, velocity becomes 0. Now you tell me one thing. What is happening with the acceleration over here? This is 50, 60, 90. Acceleration is increasing. You tell me one thing. Just before when velocity becomes 0, just before that, can I say velocity is maximum in that case? Can I say the velocity is maximum in that case? Definitely yes, velocity will be maximum in that case, just before. Now you will say, sir, at when velocity is equal to 0, at that point of time, it is acceleration is also 0. I'm saying just before velocity is 0, such that the difference between those two intervals is approximately equal to 0. We can take that interval, okay? So at that point of time, acceleration will be maximum, because from here to here, acceleration is increasing. So at that point of time, acceleration will be maximum. Okay, now let's talk about positive acceleration and direction of acceleration. This is the piece of concept that creates confusion in a lot of people. Come on, I need to know in the live chat. Okay. Acceleration is velocity change in time. Come on, man. Okay, say change in time. 230 means, I'm saying that at t is equal to 1 second, its velocity is 200. T is equal to 2 seconds, its velocity is 230. This is the example I have created accordingly. This is possible in real life. T is equal to 2 seconds. Okay, t is equal to 2 seconds. Now tell me acceleration. You'll say change in velocity. That is 230 minus 200. 230 minus 200. Up change in time. T2 minus T1. T2 is 2 minus 1. How much in this example accordingly? Come on, I need to know live in the live chat if you understood this properly. Come on. So positive acceleration and negative acceleration, okay? Positive acceleration and negative acceleration. Let me just give you the feel of this one. Now see, whenever the acceleration is in this direction, we say acceleration is positive. Keep this thing in your mind. This is just the sign convention. Whenever we say acceleration is in this direction, we say acceleration is negative. Okay, let me just give you the feel. If the car is moving from this point to this point exactly, okay, fine. In this case, can I say velocity is in the forward direction? Okay, velocity is in forward direction. Now you tell me one thing. What is happening with the acceleration in this case? 50 minus 0. 1 second. In this case, case number 1, can I say velocity? In this case, tell me, this is acceleration 50 minus 0, 50. This is 60. This is 90. Now you tell me one thing, 50 minus 0, that is plus 50, plus 60, plus 90. So this is velocity, this is acceleration, okay? This is velocity, this is acceleration. In that case, can I say over here, velocity, car is moving in the forward direction, okay? Car is moving in forward direction. Means velocity is in forward direction. What is telling you the direction of motion? Velocity always tell you the direction of motion. If acceleration is in the forward direction, never say the body is moving in the forward direction. If acceleration is in negative direction, don't say body is moving in the left direction. But when velocity is positive, means body is moving in right. When velocity is negative, body is moving in left. Okay? Over here, can you tell me, this is acceleration, this is velocity. So velocity is forward. Velocity is forward. Acceleration in this case is forward. Okay, why forward? Because acceleration is positive. Positive acceleration means when the body is in forward, when acceleration is in forward direction. Acceleration is in forward direction. Let me show you the other case as well. Now in this case, case number 2, velocity forward but acceleration backward. Understand, if body is having velocity in forward direction, acceleration will have the backward direction. Now you tell me one thing. For example, this was the case when the body starts speeding up. You started the car, you started speeding up, and initially 50, 100, 200. Understand? So this was that case. This is the case when you applied brakes. You were already moving with 200 km/h. You applied brakes. You started decreasing the speed. Can we say it like that? So this is basically what happens. 200, 150. This is happening with a velocity. 200, 150, 90, 0. Understand? Ultimately you stop. Now what is happening with the acceleration in this case? Minus 50 over here, minus 60, because 90 minus 50 is minus 60 over here. This is minus 90. Now acceleration is negative. In this case, velocity is forward because car is moving in the forward direction. But acceleration in this case is backward. And acceleration we say over here is negative. Understand? You got the feel of positive acceleration and negative acceleration? Okay, case number 3. Velocity backward, acceleration backward. Both are in the backward direction. Come on, I need to know in the live chat if everybody got the feel of this one. That's great. That's great. Now, listen to me very carefully. This car started moving in the reverse direction. Understand? It basically started moving in the reverse direction. Okay? This was stopped over here, started moving in the backward direction, reverse direction. Initially started from 0, okay, velocity 0, then minus 50, because when the car moves in the negative direction, we say minus 50, minus 110, minus 200, okay. Now in this case, could you please tell me what is the acceleration over here? You will say minus 50, change in velocity, okay. Minus 50 minus 0, how much that will be? Minus 50. Or how much over here will be? Minus 60, minus 90. In this case, velocity is backward, and acceleration is also backward, okay, backward. Acceleration in this case is negative. Keep your mind over here. You need to basically have a look properly on this one, because this is the stuff that mostly creates confusion in students, okay. Positive acceleration and negative acceleration, these are the most important cases. Nobody will tell you this for sure. Watch any video, okay. Now in this case, can I say this is velocity? The car was already moving with the 200 kilometers per hour in the backward direction. Now it applied brakes but in backward direction. So minus 200, minus 150, minus 90, 0. In this case, minus 150 minus 200, that will be, this is minus 150, change in velocity, minus 150 minus into minus 200. How much this will be? This is plus 200 minus 50, that is plus 50. So plus 50 plus 60 plus 90, this is acceleration. So in this case, velocity is backward. Acceleration is what? Forward. Okay, the car is moving in the backward direction, still acceleration is in forward direction. Come on everybody, I need to know if you are loving this lecture. Like this video as soon as possible. Hit the like button, all of you. Okay? And acceleration is forward. We say in this case, acceleration is positive. Velocity is negative. Just the reverse, just the opposite process of velocity. Come on, now we have the question. I want everybody of you to solve this. Okay, so we are given a velocity. What is happening with this one, man? Okay, so we are given a velocity time relation. A car is moving, its velocity at different times is different, okay. This car is moving in the forward direction, its velocity at different points is different, depends upon the time, okay. So this is given relation. We are supposed to find average velocity from 0 to 2 seconds, instantaneous, AINS, instantaneous acceleration, not a velocity, instantaneous acceleration, average acceleration and instantaneous acceleration at t is equal to 4 seconds. Okay, so can we say this average acceleration is nothing but delta V by delta t, okay, that is V2 minus V1 upon T2 minus T1. Now find what is the value of V2. V2 is basically when t is equal to 2 seconds. V2 is when t is equal to 2 seconds. That means put the value of 2 seconds over here. So it will be nothing but 2 into 2 square plus 4 into 2. How much that is? That is nothing but 16. Okay, 16. What is the value of that? Will be 0. Okay, that will be 0. So can I just put it over here? The same. It is nothing but 16 minus 0 upon 2 minus 0. It is nothing but 8 meter per second square. 8 meter per second square. I'm not moving the camera, okay? 8 meter per second square. Now tell me average instantaneous acceleration. AINS is nothing but dV by dt. Can I just differentiate that in order to get the instantaneous acceleration? That is nothing but dV by dt. That is nothing but 4t plus 4. Okay, that will be 4 into this 4 plus 4 is 20 meter per second square. 20 meter per second square. Next question. Now you can do this by yourself. We are given acceleration and we are supposed to find velocity. We need to do the reverse process. As acceleration is dV by dt. Now if I ask you to tell me velocity, you'll do the reverse process. You'll integrate. So take it over there. So this will be dV is nothing but integration. dv is nothing but this a dt. Now integrate. If you integrate. When you integrate small dv's, it will give you big dv. That is what? Delta v is nothing but integration of, instead of this, you put 6t plus 6. Understand? And find v after t is equal to 5 seconds, from 0 to 5. 0 to 5. Understand? And you can just write it. This is v minus u is integration of 0 to 5, 6t plus 6 dt. And it is saying that starts from rest, means vu. Delta v is what? Change in velocity. Final velocity minus initial velocity, means starts from rest. Initial velocity is 0. V minus 0 is integration of 6t plus 6. And this will be dt from 0 to 5. Now solve this by yourself and tell me the answer. Come on. Same question over here. Same question over here. Now, we're given the acceleration over here. I'll tell you after some time. There was a question on, the question came in JEE Mains 2021. Okay. Now, acceleration time relation is given. You are supposed to tell me the position time relation and velocity time relation. You just have to basically integrate in order to do the reverse process. Fine, that is what you are supposed to do in this question. Fine, everybody is understanding, or am I moving too fast? I need to know in the live chat. Okay, let's move on to the next question. Come on. This was the question asked in JEE Mains 2021 July attempt, okay? You just have to tell me the answer of this one. Can you just tell me A, B, C, D? Which option is correct? Which option is correct in this one? This was asked in JEE Mains 2021 July attempt. Come on, all of you. Yeah, I don't know what is happening with this one. 1 second, 1 second. I need to check the Wi-Fi settings. So, if the stream disconnects, wait for just 2 seconds. I'll start it once again, okay? Everybody. Because there is some internet. Am I live? Am I live? Can you hear me? Can you hear me? Come on. Okay. I'm just fixing it, man. I don't know what has happened to the camera. Okay, come on. I want all of you to answer me this question as soon as possible. Come on. So, the relation between time and distance for a moving body is given like this. Okay, T is equal to mx square plus nx, where m and n are constants. The retardation of the motion is, a body is basically moving. In that body, the time and distance relation is given. Understand? Now, you are supposed to tell me the retardation of that body. Means acceleration, or whatever you say, negative acceleration. Find that. It has to be negative basically. Can you tell me A, B, C, D? Which option is correct? Can you solve this? This was asked in July attempt recently. Very simple question on the same concepts. Whatever I'm teaching you, on the same concepts only. I don't know what has happened to this one. Come on, man. Okay. So, A, B, C, D. Which option is correct? So, the time, distance and time relation of a body is given like this, where m and n are constants. The retardation of the body is, you are supposed to tell me the retardation of the body, okay? Now, first of all, if you are supposed to find acceleration, retardation, whatever it is, from this one, first find the velocity. Afterwards, let's see what's gonna come. So what is the relation that is given from this side, that side? Listen to me very carefully, have a look on this one. So can I just write t is equal to, this is nothing but mx square plus nx. I'll just write it over here. So I'll just write t is equal to mx square plus nx, okay? Do one thing. We are supposed to find the velocity. Do one thing, differentiate with respect to x over here. So can we just write dt by dx is nothing but d by dx of this mx square plus d by dx of nx. Why are we doing this? Because we need to find the velocity. After velocity, we'll find the acceleration. That is the simple step, okay? Now, because this distance time relation is given, find velocity, find acceleration afterwards, okay? Come on. So can I just say, so this will be, this is x, okay? So this will be basically dt by dx, okay? So can I just say over here, how do you differentiate in this case? So can you just tell me this is 2mx, power down, power minus 1, m you take as a constant over here. For this one, it will be nothing but n only. This is n times of x. So differentiate. Now you do the reciprocal of this one. So can we just write that will be dx by dt. It will come out to be, that is 1 upon 2mx plus n. Fine. So now dx by dt is what? That is velocity. Velocity is 1 upon 2mx plus n. So we got the velocity. Now we can find, so we can basically find the acceleration now. Somebody is saying your teaching level is same in Unacademy and YouTube. What are you talking about, man? I haven't started any course on Unacademy yet. Okay. Now, if you basically want to find the acceleration from this point, from this velocity, what you're going to do? Differentiate with respect to time. So it will be dv by dt. Understand? Now you need to differentiate this also. So for that, you will use basically uv. So this is, consider this as u, consider this as v. How do you use the uv rule? Where should I write? Okay, we have space. So use this rule. If I say, for example, u by v, differentiation of u by v, how do you do this? You basically write v as it is. You write this v as it is, du by dx, exactly. Then minus of u as it is, dv by dx, then v square. Do the same process in the next step. So can I just write v as it is, that is 2mx plus n, that is 2mx plus n as it is, and the differentiation of this u, differentiation of 1 is 0 minus, then minus u as it is, that is 1, u is this one, and differentiation of this stuff. How do you differentiate this one with respect to time? So you will say that is 2m, and this will be dx by dt, this is d by dt of 2mx. So this is constant, so d by dx, for this you will say dx by dt plus differentiation of this is what? That is 0. Understand? And you will just write that is 2mx plus n, its whole square. 2m and x plus n, whole square. So now from this, can we just write, this will be minus of 2m dx by dt, that is v, upon 2mx plus n, its square. You tell me one thing, what is this 2mx plus n? 1 upon 2mx plus n, 1 upon 2mx plus n. This is v. So we can put instead of this v over here. So it will be nothing but minus 2mv. Instead of this 1 upon this, we'll put v square, because this is square over here. So it will be v square. So can I just write now? It will be nothing but 2mv cube. 2mv cube. Which option is correct? Minus 2mv cube. Minus is why? Because this is a retardation. This is a retardation, okay? Yeah. Okay, everybody understood this? Or do you want me to repeat? Everybody understood this? What are the steps I did? Come on. Do you want me to repeat? Everybody. You understood that this was recently asked in JEE, okay? I'm asking you. Next question we have on the screen. These are some of the beautiful questions that I suggest you to basically solve. Okay? Come on. Tell me. Now, acceleration of a particle moving along x-axis is defined as this. Okay? There is a particle. There is a particle. There is a particle, understand? That is moving. Acceleration is like this. Acceleration is given in terms of displacement. A is equal to minus 4x. At any instant t is equal to 0. At any instant t is equal to 0. The particle passes the origin with a velocity of 2 meters per second. Understand? At any time t is equal to 0. See, acceleration of a particle is given this. It is saying that if that particle is moving, when time t is equal to 0, if this is origin, when time t is equal to 0, it is passing the origin. At time t is equal to 0, x is equal to 0 because it is passing the origin. But what is the value of velocity? With what velocity it is crossing? 2 meters per second. Understand? It is saying that acceleration of a particle, for example, this is a particle moving, its acceleration is how much? Minus 4x. Understand? Its acceleration is minus 4x. Now, when it is crossing the origin, at that point of time, time is 0. Understand? At time t is equal to 0, it's crossing the origin with velocity 2 meters per second. What we are supposed to find, that is its velocity as a function of its position coordinates, its position as a function of time. Can you people solve this? I want to know the answer of this in the live chat. Come on, man. This is a very good question. It's a very good question. I suggest you to solve this at your own. Before I do it, you people are supposed to solve this. Understand? Come on, all of you. I'm waiting for your answers as well. Okay? All of you over here, solve this question as soon as possible. As soon as possible. Tell me, can you solve this question? Can you solve this question in the live chat? Now see, what we are supposed to do over here. Acceleration is given like this. See, we need to find velocity as a function of position coordinates. I simply will suggest you to use this formula, as acceleration is basically in terms of displacement only. Use this. A is equal to v dv by dx exactly. Fine. Take this over there. Can we just take it over there? I'll just write it over here. Can we just write it? A is equal to v dv by dx, because this was the formula of acceleration we know. Let me just tell you how it comes exactly. A is equal to dv by dt multiplied by dx over here, divide by dx over here. Now interchange. So can we just write dv by dx? When we take it over there, multiply, this will be dx by dt. Can we just write A is equal to dv by dt is dv by dx? Keep it as it is. dv by dx. What is dx by dt? Rate of change of displacement with time. That is nothing but velocity. That is v dv by dx. v dv by dx. Okay, everybody. So take it over there. So it will be A dx is nothing but v dv. Okay. Now what you are supposed to do is integrate. We need to find the velocity as a function of position. From acceleration, we are supposed to find the velocity. Means we need to do the reverse process. We need to do the integration stuff. Now, if a velocity was given and acceleration was asked, in that case, we need to differentiate. Here, we need to do the reverse process. Now, integrate in that case, okay? Now say, integrate from where to where exactly? It says that, see, look at the question itself. At any instant t is equal to 0, the particle passes through the origin, means with a velocity of 2 meter per second. Means when x is equal to 0, means at origin, when particle was crossing origin, its velocity was 2 meter per second. So its velocity was 2 meter per second. I say, after some time, when velocity is something v, it has crossed some displacement. When it has basically covered some displacement, at that point its velocity is v. Simple. This is how you are supposed to put up the limits. Understand, everybody? This is how you are supposed to solve these questions. Now listen to me very carefully. See, in this case, how do we exactly do this? What is acceleration given? That is minus 4x. Put it over here. That is minus 4x from 0 to x dx exactly. It will be nothing but integration of this v dv from 2 to v exactly. Now do the integration stuff over here. When you integrate this, minus 4 will come out. Integration of this x, that will be nothing but x square by 2 exactly from 0 to x is equal to this. It will be v square by 2 from 2 to v exactly. Listen to me very carefully. What are the steps I am following? You need to follow the same steps in the next question as well, okay? So can I just write, it will be nothing but 2x square. When you put the value of x as x first, then 0, it will be only minus 2x square over here. So over here it will be what? V square by 2 minus 2 square by 2 exactly. Now, so can we just further simplify? 2x square is nothing but, so 2x square is nothing but, it will be 2v square minus, this will be 4 into 2, that is 8 upon this 4 exactly. So 2 will exactly cancel over here. So it will be nothing but minus 2x square is equal to, so it will be v square minus 4 upon this 2. So further, if we simplify this, can we just write it? Take it over there. It will be minus 4x square is nothing but v square minus 4. Okay. So take it over there. So v square is nothing but, it will be 4 minus this. This is minus 4. It will go plus 4. 4 minus this 4x square. Fine. So v is nothing but a root of 4 minus 4x square. 4, take 4 common and take it out. So it will be nothing but 2. Root 4 is 2. So 2, it will be 1 minus x square, root of 1 minus x square. So this is the velocity as a function of position. Velocity as a function of position. Okay, I hope you understood this. Velocity as a function of position. Now what we need to find exactly is its position as a function of time. Position as a function of time. So for that, what formula we're gonna use? That is nothing but v is equal to ds by dt clearly. Now velocity as a function of time we need to find. We'll use the same formula. Now you tell me one thing. Put it, take this velocity. Now here also velocity is given. You are supposed to find the position. Means you do the reverse process. You do the integration process. Understand? Which 2x square? This 2x square, you are asking me, put the value first as x square. Okay, x square by 2 minus this by 2. Take this 2 common. 2 will get cancelled off. So this is x square minus 0 square. So this will be x square. So 2 and this 2. 2 ones 2 2. So minus 2 into x square. This 2x minus 2x square. Just the simple mathematics. Okay. So can you just put it over here? This is v is equal to root 2 root of minus x. So instead of this, we will put 2 root of 1 minus x square over here. It is a ds by dt exactly. Now tell me one thing. Take this over here. Put instead of this s, just write x because it's one and the same thing. Just write x, just write because this is in terms of x only. Okay, it will confuse you. So displacement, understand? Now take it over there, keep it over there. So it will be 2 dt is nothing but dx by root of 1 minus x square exactly. The root of 1 minus x square exactly. Now you tell me one thing. Why did it put over here? Because we have x square over here and over x square over here. Same terms, understand? Same variables. Now do one thing. Integrate this one. Integrate this one. Now the question is from where to where we are supposed to integrate in this one. Now see, it is saying that when particle at time t is equal to 0, particle passes the origin, means at t is equal to 0, x is equal to 0. So means at t, instead of at t is equal to 0, x is equal to 0. After some time, when it has covered some displacement x, I would say time is t at that point of time. Fine. So it will be nothing but 2t. From 0 to t, it will be 2t only. So it is nothing but integration of, that is 1 by root of 1 minus x square. You might have studied in your integration stuff. That is, its integration is nothing but sine inverse of x. Understand? So sine inverse of x, take this over there, sine over there. So x will be nothing but sine of 2t. So this is the position in terms of time. Position as a function of time. Position. Yes, you will definitely get the 99 percentile. You don't have to be. Okay. The people who follow us, they can solve all of these questions within second. Okay. You compare this much of information with the other videos. Okay. Yeah. So you got the position as a function of time over here. Position as a function of time that we were supposed to find. First was velocity as a function of position. Velocity as a function of position. Velocity in terms of position. Second, position as a function of time. Okay. Join our Telegram channel, JEE English Unacademy. Over there, we share the notes. I'll be sharing the notes over there of this one as well. Now, this is the same question. I want you people to solve this at your own. This is home work. I need you people to basically comment the answers in the down below. So comment down below the answers, all of you. Okay, so over here, acceleration is given in terms of velocity. A is equal to minus 2v, and at any time t is equal to 0, the particle passes the origin, means x is equal to 0 with a velocity of 2 meters per second. Exactly same. Now here you need to find velocity as a function of time. Previously you were supposed to find velocity as a function of position. Here you need to find velocity as a function of time, position as a function of time, velocity as a function of position also. Understand, this is all stuff that you can solve. Over here you start with this equation, a is equal to dv by dt. Now you take it, instead of this a you put this minus 2v is equal to dv by dt. You take it over there because velocity is take it over here. So this will be minus 2 dt is equal to dv by this v, dv by this v. Keep on solving this, you will get the answer. All of you put no, you don't have any special class today. Okay, all of you comment down below the answers. I'll be waiting. Now let's move on to the position time graph. Tomorrow we'll be having detailed one shot of what do we call that, calculus or basic mathematics. Basic mathematics / calculus. Okay, calculus only, not the entire basic mathematics. You will ask me, sir, please. One shot lecture is there, sir. For what? For kinematics. This is the kinematics one shot. So now we have this position time graph. Can you guys tell me what is the definition of position time graph? Very simple definition, normal definition, common definition. Now see, let me just tell you what is this position time graph, displacement time graph, whatever you say. Okay, now if this car is traveling in the forward direction, after some time at t is equal to 1 second, I am looking at the clock, at t is equal to 1 second, it covered 1 meter. After t is equal to 2 seconds, its displacement is, its position is 2 meters. After t is equal to 3 seconds, 3 meters. After t is equal to 4 seconds, 4 meters. I am asking you the simple question, very simple and common question, that plot the same situation graphically. Plot the same situation graphically means plot the position time graph of this example. You will say it is very simple. Now I'll plot the position time graph of this. Okay, basically I want you people to represent this example, represent this situation graphically in terms of position time graph. You will say it is over here S, over here T, displacement, time, means when time T is equal to 1 seconds, when time it is 1 seconds, displacement is 1 seconds, means the point is over here. Because time is 1 seconds, displacement is 1. When time is 2 seconds, displacement is exactly 2. When time is 3, displacement is 3. When time is 4, displacement is 4. So will the graph be something like this straight line? 100%. So can I say that the position time graph of this example, this situation is like this? 100%. That's all. This is the definition, very simple definition of position time graph. Similarly, you will be giving different number of situations, different number of examples in your life. You will be asking, draw the position time graph of this situation. You have to draw it. This was a very simple example. Okay, you'll be getting the complex examples in the upcoming time, and you'll be given, draw the velocity time graph of this situation. You'll have to draw it. Draw the acceleration time graph of this situation. You have to draw it. That's all. Now let me just tell you what is slope. What is slope? Anybody in this class who actually knows what is slope? Slope is nothing but rate of change of y with respect to x. Understand? Let me just give you the feel. People say slope is nothing but rate of change. People say slope is nothing but tan theta. What is that exactly? Let me just tell you. For example, this is a inclination over here. Okay, this is an inclination over here, or I'll just tell you in just a second. Okay, it's gonna take a lot of time. So let me just tell you, this is having, slope is nothing but steepness. How much steeper is this? This is more steeper. This is less steeper. Zero slope, no slope. How much inclined is this? This is more steeper, more steeper. This is inclination. This is having maximum inclination, infinite slope. Understand? So same is the case over here. This is having less slope as compared to this one. Understand? Now if I ask you, how much is the slope over here? You will say slope is, how do we exactly calculate this slope? You will say, sir, slope, we calculate that is steepness. Steepness, how do we calculate that? You will say simply, sir, that is nothing but this perpendicular upon this base. More the perpendicular, more will be slope. Increase the perpendicular, slope will increase. Decrease the base, slope will. In this case, perpendicular is less, slope is less. Base is more, slope is less. So can I say it is nothing but perpendicular upon base? In which quantity in mathematics you say perpendicular upon base? That is tan of theta. Okay, so now tan theta, theta is more, slope is more. Understand? Slope is more, tan theta is more. Now further, if we just write it, perpendicular in this case is how much? If I say, for example, this is y, tell me the line, slope of this line. You will say simply that is what? Tan of theta. How much tan theta? Perpendicular by base. That is how much is the perpendicular? This y. Understand? This y. This much is the perpendicular. Understand? That is over here. This is y2. Over here, this is y1. So this will be y2 minus y1. Over here, this is x2 minus x1. So can I just write this is y2 minus y1 upon x2 minus x1. Change in y. How much you have traveled in y? How much you have traveled in x? That is delta y by delta x. So slope between any 2 points is nothing but delta y by delta x. Now if I ask you to tell me the slope at a point, in that case you will say nothing but that is dy by dx is slope at a point. Fine. Now slope in xt graph. What does this slope mean in xt graph? Okay, sir, please go slow, sir. Am I going too fast? These are very basic concepts. Okay, okay, fine. Okay, fine. So basically in this case, slope is nothing but y2 minus y1 upon x2 minus x1, that is delta y by delta x. Because what is between these 2 points, I'm saying that how much is the change in y? Large change in y. That's why delta y delta x. At any point, single point, what is slope? That is dy by dx. Why dy by dx? Because at that point change in y will be very small. change in x will be very small. So that is nothing but slope at a point. Now, what is slope in case of a displacement time graph? If a car is traveling from this point to this point, okay? This car is traveling from this point to this point. I'm asking you to tell me how much is change in displacement from A to B. You will say change in displacement we have studied previously. That is nothing but S2 minus S1. If I say over here displacement is S2, time is T2. Displacement over here is S1, time is T1, okay? S2, S1, or 100 minus 0, T minus 0, it's something like that only. So upon T2 minus T1. So you'll say S2 minus S1 is what? That is a delta S. T2 minus T1 is what? That is a delta T. Fine. Change in displacement. Change in displacement upon change in time. So what do we call this previously? Nothing but average velocity, VAVG. Okay. Now let's come on to, if I ask you to draw the same situation graphically, this is S and this is T. Everybody is understanding, able to understand everything I need to know in the live chat. Drop a CC, crystal clear. So ST graph over here, if I ask you to tell me what is the slope of this line, if I draw the same situation graphically, it's a graph is coming out to be the straight line. If I say this is nothing but theta, what is the slope of this straight line? You will say slope of this straight line is, sir, between these 2 points, it is nothing but over here, what is the value of S? That is S2. Over here, what is the value of S? That is S1. What is the value of over here? That is T. That is a T2. It is T1. So tell me the slope. You will say perpendicular by base. This is perpendicular, this is base. How much is this perpendicular? You will say, sir, S2 minus S1. S2 minus S1. T2 minus T1. Now tell me how much is the slope over here? You will say, sir, slope is nothing but S2 minus S1 because perpendicular upon base T2 minus T1. What is S2 minus S1? Delta S. What is T2 minus T1? Delta T. What is this delta S by delta T, bro? This is nothing but average velocity. Means that slope of displacement time graph represents average velocity between any 2 points, or simply slope of displacement time graph represents velocity. Can I say it like that? Slope of displacement time graph represents velocity. Now see, slope, because this is the proof, because we represented same situation graphically, its slope came out to be the same. Slope of ST graph represents what? Velocity. Fine, that's all. Now if I ask you, this is the question over here, tell me what is the slope in this case. S is equal to 10 meters, means at 10 meters it is at rest. S is equal to 10 meters. This is displacement time. So S is equal to 10 meters. The graph will come out to be the straight line. Okay. Now in this case, could you please tell me what is the velocity? By if this is at rest, means velocity will be 0. What is velocity? Means ds by dt will be 0. Obviously it has to be 0. Displacement is not changing with time, means at time t is equal to 1, displacement is 10. At time t is equal to, displacement is still 10, and time t is equal to 3, displacement is still 10. Means I'm at rest, time is changing, means velocity is 0. Understand? So ds by dt is 0, velocity is 0. Now check from the slope point of view. Can you tell me the slope of this line? You will say slope is nothing but tan of theta. How much is theta? This line is parallel to this one. So theta is nothing but 0 degrees over here. So tan 0 is 0, means slope is 0. Means in this case, slope is 0, velocity is 0. Yeah. Positive slope and negative slope. Most important case, listen to this very carefully. If I say, for example, this is y can be any quantity. I'm taking y, x, y is any quantity. Right now, previously, I'm taking s and t, that is displacement and time. Over here, y can be any quantity, x can be any quantity. So y, x. If I say the graph is this is x, this is y. If I say the graph is something like this. Okay. Now you tell me one thing. You tell me one thing. If, see what is positive slope and what is negative slope. If this theta is less than 90 degrees, slope tan of theta, the value of tan theta will come out to be positive. Means slope will be, because tan theta is slope will be positive. Keep this thing in your mind. Clearly we can say this graph is strictly increasing, so it will have slope that is positive slope, and this is negative slope, this is having negative slope. Now over here, theta, if theta is greater than 90 degrees, less than 180 degrees, in that case slope is negative. Understand? Over here you can clearly see y is a decreasing with x. Understand? So change, what is slope? Change in y, change in this quantity upon this quantity, that has to be negative. Over here that has to be positive. Y is changing with x, increasing with x, it has to be positive. Positive slope, negative slope. Now in this case, if the graph is something coming out to be like this is the analysis of the graphs. If the graph is coming out to be like this, can you tell me what is the velocity of this car if the car is having this graph? Can you tell me in the live chat? I would simply say in this case slope is what? Slope is negative, because theta is theta is greater than 90 degrees, theta is less than 180 degrees. So means if slope is negative, slope in case of displacement time graph represents velocity. So in this case, velocity is what? Negative. So means in this case, car is moving in the left direction. When reaches origin, for example, when reaches origin, this is at origin, x is equal to 0 or s is equal to 0. It still keeps on moving in the left direction. So still slope is basically negative. Yeah. Now in this case, this is ST graph. Could you tell me please what is the slope? You'll say slope is basically in this case positive, because theta is making what? Less than 90 degrees. Slope is positive, means the velocity in this case is positive. Car is moving in the right direction. Tell me in this case, most important case. Okay. In this case, can you please tell me what is the slope in this case? You will clearly say slope in this case is basically increasing at any point. Listen to me one thing. See, in case of a straight line, you told me slope between any 2 points. Okay. Now if I ask you to tell me the slope at a point, you will say slope at a point is nothing but tan theta. Over here theta. See, theta is same means tan theta is same. At every point, slope is same. Understand? So means that in case of a straight line, slope between any 2 points is same. Slope at a point is basically same. Now, if I say this is a displacement time graph, in this case, slope is not increasing. Okay. Yeah, in this case, yeah, it is increasing, but in this case, it is constant. If if the line is like this, slope is 0. And if the line is like this, slope is constant. Slope is constant. Understand? Slope is constant in this case. You getting me what I'm trying to say? In this case, slope is 0, but in this case, slope at every point, slope is same. At every point, slope is same. Okay. Now, in this case, slope is changing. Over here, at this point, slope is this. At this point, slope. See, theta is changing. This theta is less. This theta is more. This theta keeps on changing. So slope is increasing. In this case, slope is increasing. Keep that thing in your mind. And how to find slope at a point in case of a curve? You take a point, draw a tangent, and find how much theta it is making with the x-axis. Then you find slope is nothing but tan of this theta. Tan of this theta. That is what? That is nothing but dy by dx that I told you at a point. Fine. In case of a straight line, it's same. In case of a curve, it's changing. It's changing at every point. Come on, everybody understood this. I need to give me some signals in the live chat that yes, sir, understood, crystal clear. Done with the water, man. Okay, now let me just have a look on this one. In this case, slope is definitely increasing. Now you tell me one thing. Can you just comment on velocity and acceleration? Now see, in this case, I'm saying that acceleration is constant. Acceleration is positive. Velocity is clearly increasing. Velocity is increasing means uniformly increasing. Increasing uniformly. Why? Let me just tell you. Take this equation. The equation for this is s is equal to t square. Now differentiate this, ds by dt. You will get velocity. So that will be differentiation of this is nothing but 2t. Means slope is what? Constant, 2t. Slope is constant, 2t. Slope of this line, it is something like this. Bend towards, if this is st, bend towards what? Towards the क्या नाम है इसका? S, this axis, understand, 2t. If I say this line, it is y is equal to x. This is, if this is yx, this is y is equal to 2x, understand, towards this one, understand? Fine. You getting me what I'm trying to say? So that's why in this case, so it is slope constant. This is the information that you should have studied in your calculus, okay? This is the extra piece of information that I'm giving you right now. So this, now again differentiated, that is a dv by dt. You will get what? Acceleration. That will come out to be nothing but 2. So acceleration is constant 2. Acceleration is constant 2 in this case. Acceleration is positive. Acceleration is positive. Velocity is increasing uniformly. Okay, fine. Now analysis of this bowl, one of the greatest concepts in this position time graph. Now see, from this point to this point you are traveling, understand? If you say, for example, the graph of a straight line is coming out to be this, we'll divide this bowl in 2 different parts. That is the first one, the second one. Okay, now you tell me one thing. From this point to this point, you can clearly see that slope is a decreasing. At this point, this is slope. This point, this is slope. This point, this is slope. At this point, the slope is 0. Why? Because the tangent is parallel to this x-axis, means slope is 0, means that there is no slope. At this point, there is no slope. In case of displacement time graph, slope is 0, means a ds by dt is 0. Means a velocity is 0 at this point. Car stops. So means displacement decreasing. At this point, slope decreasing, it becomes 0. So from this point to this point, displacement is decreasing, velocity is also decreasing. Why? Then only velocity becomes 0 at this point. Everybody is basically able to analyze these graphs, okay? And from this point to this point, what happens? We say displacement is increasing. See, displacement is increasing, and velocity is also increasing. Why? Because slope is increasing. Now see, slope over here, increasing. Understand? Yeah. So from this point to this point, displacement is increasing, velocity is increasing. And you can clearly check from this point also, slope is negative, velocity is negative. Body moving in left direction. From this point to this point, slope is positive, body moving in positive direction. Now, can you solve this question? VAVG from 0 to 2 seconds, from 2 to 4 seconds. You tell me average velocity from 0 to 2 seconds. If a graph is coming out to be like this, can you tell me the average velocity from 0 to 2 seconds? Hey, if a displacement time graph is given, you are supposed to find the velocity. Find slope, because slope of a displacement time graph gives you the velocity. So slope over here, slope from 0 to 2, that is nothing but gives you the velocity. That is nothing but delta s by delta t, perpendicular by base. This perpendicular upon this base. So how much that is? That's s2 minus s1 upon t2 minus t1. So what is s2? Means at t is equal to 2, how much is displacement? That is a 10 minus. How much is this base? This 10, and this is 0 upon t2. That is 2. 2 minus 0, it is coming out to be 5 meters per second. And see, this is coming out to be positive, means slope is positive. Slope is positive means the velocity is positive, body moving in right direction. Similarly, for this one, slope, velocity will come out to be negative, because slope is negative, and it will come out to be 4 to, from 2 to 4, 2 to 4, 10, 5, it will come out to be minus 2.5 meter per second. Now, this graph, I want you people to tell me what is the velocity time graph of this one, okay? The displacement time graph is given like this. Its velocity time graph will be, come on, this one. Tell me, I told you previously, this means s is equal to t square. Differentiate it, that is a ds by dt will give you the velocity, means the velocity is 2t. Okay, means velocity is 2t, changing uniformly, Tell me in which case, and in this case clearly you can see slope is positive, so it has to be positive, not negative. Over here velocity is constant, so this cannot be 1. Velocity is changing uniformly, understand, previously I told you, so this cannot be 1. This one here velocity is changing uniformly, yeah, this can be 1. Here velocity is changing uniformly, this can be the 1. This, no, definitely not. This is basically velocity time. Now you tell me one thing, in this case velocity is changing uniformly but slope is negative, means in this case acceleration is negative, understand? Are you getting me what I'm trying to say? In this case acceleration is negative. If you find the acceleration over here, that is coming out to be positive, okay, because that is coming out to be 2, so that is positive. In this case velocity time graphs, slope is nothing but acceleration, that is negative, so this cannot be 1. This is the answer. C, how can it be B? Come on, it's acceleration time graph, same, S is equal to t square. I told you its acceleration is constant, its acceleration is positive, so which option? Here acceleration is changing uniformly, no, here changing uniformly negative, understand, slope is negative, here jerk is negative. I'll tell you what is jerk also, okay? Here this is not, acceleration is negative, constant negative, acceleration is positive, above the x-axis it is positive and it's constant, this one. Yeah, let's move on to the velocity time graph. Fine. I'll get some water, give me 2 seconds, okay? Give me just 2 seconds, I'll get some water. Wait for me just 2 seconds, man. Somebody tell him my Telegram ID. You can either join JEE English Unacademy or mine. That is Yawar Manzoor. Okay, Yawar Manzoor only. Okay, so now velocity time graph. As I told you previously, like we plotted the position time graph of a particle, same we need to plot the velocity time graph of a particle. Now, if I ask you, if I tell you, for example, this car is moving in the forward direction, after 1 second, its velocity is 1 meter per second. After 2 seconds, its velocity is 2 meter per second. After 3 seconds, 3. After 4 seconds, 4. So this is the situation. This is the velocity time graph. This is the situation over here of this car. I'm asking you to plot the same situation graphically. Plot its velocity time graph. You'll simply say that is nothing but this v and this t. So at t is equal to 1 second, it's this. 2 seconds, 3 seconds, 4 seconds. Okay, so it'll be a straight line. So this is the velocity time graph of this situation. slope of velocity time graph. If, for example, I'm saying the car is traveling from this point to this point, okay? The car is traveling from this point to this point. I'm asking you the simple question over here. Tell me, how much is basically the change in velocity from this point to this point? You will say change in velocity from this point to this point is, for example, over here it is V1 at T1, V2 at T2. Can you tell me change in velocity? You will say simply, sir, it is nothing but delta V, V2 minus V1 upon delta T. That is nothing but what? Acceleration. Change in velocity from A point to B point, that is nothing but acceleration. Fine. Now, if we plotted the same situation graphically, for example, if you say its graph came out to be the straight line, for instance, you assume that, okay? Now, if I ask you to tell me the slope of this one, you will say, sir, slope is simply, the slope is tan of theta. Tan of theta. So in this case, that is nothing but what? This perpendicular upon this base, perpendicular upon this base. How much that is? So you will say perpendicular is, it is V2 over here. If it is V1 over here, it is T2 over here. It is T1 over here. Understand? So this perpendicular is V2 minus V1. This base is T2 minus T1. So can I just write V2 minus V1? V2 minus V1 upon T2 minus T1. So can we just write it nothing but V2 minus V1? It is nothing but delta V by delta T. What is that? Delta V by delta T is nothing but acceleration. Means slope of velocity time graph gives you the acceleration. Slope of velocity time graph gives you the acceleration. From now onwards, if you are given the velocity time graph, if somebody asks you to tell me how much is the acceleration, you find the slope of that velocity time graph, you will get the acceleration. Same as like the previous case. Now, slope of velocity time graph in case of a curve, okay? In case of a curve. If I say, for example, from this point to this point, velocity is not constant. Velocity is changing. Understand? In that case, if the graph is, for example, coming out to be something like this, you assume that. If the graph is coming out to be something like this, fine. Now, if I ask you to tell me in this case, tell me the slope at a point. How do you find the slope at a point? You draw a tangent, you find how much it is basically creating in this one, how much theta is creating in this one. You'll say, sir, simply slope is nothing but, that is a tan of theta, is nothing but how much? That is a dv by dt, not a delta v by delta t, dv by dt. Fine. Now, if in this case, velocity is changing from this point to this point, if I ask you to tell me at any particular point, you tell me how much is the change in velocity. I'll say, sir, it's very simple. That is dv by dt. What is this? This is acceleration, but instantaneous. Previous acceleration was average from A point to B point. So this is slope between any 2 points gives you the average rate of change, average acceleration in case of velocity time graph. Same is the case over here. So means at a point in case of velocity time graph, it gives you the instantaneous acceleration. Everybody understanding this properly? Very basic concepts, very simple concepts. Fine. Now, the point next one is area under the velocity time graph. Next point is area under the velocity time graph. What is area under velocity time graph? Now see, if I say, for example, from this point to this point, you are traveling, okay? If you are traveling from this point to this point, your velocity is 10 meters per second constant. If I ask you to tell me the distance or displacement, you will say simply displacement is nothing but velocity into time, that is v into t, that is nothing but 10 into 5, that is coming out to be 50 meters. So you have covered 50 meters from this point to this point by using the 9th class formula. Now, if I ask you the same situation I'm plotting graphically, tell me how much is the area under this line, area under this line. You will say, sir, area under this line is the square of the area of this rectangle, that's length multiplied by breadth. You'll say area is length. How much? From this point to this point. If I say this length is how much? For 5 seconds, its velocity remains 10. So 5. So that is nothing but 10 into 5. So it will be nothing but 50. Means area under velocity time graph represents displacement. Understand? Very simple concept. Area under velocity time graph represents displacement. Like over here, we plotted the same situation graphically. The area under this graph, this line came out to be the same as that one. When velocity is not constant, in that case, how do you find the area under the curve? So in that case, you use basically the concept of integration that we have studied in our calculus, okay? Now, over here, from this point to this point, velocity is not constant at any particular point. If you are supposed to, or you are supposed to find displacement from this point to this point, how you can find, simply use the concept of differentiation, that is nothing but, integration. So what you gonna be exactly doing to find the displacement? In that case, what you people are supposed to do is S is equal to integration of v dt. How you will get that? Let me just show you. See, we say velocity is nothing but ds by dt. Take it over there. So ds is nothing but v dt. Now integrate it. You will get S is equal to integration of v dt. Integration of ds is nothing but, integration of ds is nothing but what? It is nothing but total displacement from A to B. This is v dt. From where to where? From this point A to B, or from T1 to T2. Just write T1 to T2. Fine. Now same is the case over here. If I say this, if we plot the same situation graphically, its graph is coming out to be something like this. You tell me this area, how do you find? You basically cut a strip over here, you find the area of that strip, then keep on adding the area of all these strips. Understand? Then how do you add all the area of all these strips? By integration. So here area you will find by integration. Integration area under this curve, that is this area, that is v into dt. Exactly, you might have studied this previously, that's why I'm not explaining you that much. Okay, simply you just keep this thing in your mind. Area under velocity time graph gives you the displacement. In case of where velocity is not constant, you use the concept of integration that I told you before also. The same case is over here. Now velocity is basically 10 meters per second. Fine, everybody able to understand this? Any confusion? Come on. I need to know in the live chat. Any sort of confusion you people have? In anything? Okay, that's great. If I say velocity is 10 meters per second, it is something like this. Okay, 10 meters per second. How much is the slope? You will say slope, sir, in this case is nothing but slope is 0. Why is slope 0? Because slope is theta is 0. Tan theta is 0. Slope is 0. Clear? Okay. Tan theta is 0. So in this case, can I say basically acceleration is 0? Yes. Because what do we say? This slope of velocity time graph represents acceleration. So acceleration is 0. Now same over here. Slope is basically, in this case, velocity is negative, but slope is positive, means acceleration is positive. So in this case, slope is positive. Can I say it like that? Definitely. Why? Because theta is less than 90 degrees. Theta is less than 90 degrees. Analysis of bowl. Once again, from this point to this point, slope is a decreasing. Slope is decreasing. At this point, slope becomes 0. At this point, slope becomes 0, 100%. Okay. And when the slope is decreasing, slope of velocity time graph represents acceleration. Means from this point to this point, velocity is decreasing. Clearly we can see over here velocity will be 50, 30, 20 and something over here 10. And acceleration is also decreasing. From this point to this point, it is something like this. Velocity is increasing. Acceleration is also increasing because slope is increasing. See, slope is increasing. Fine. Same, this is the opposite of that one. From this point to this point, what is happening with the velocity? Velocity increasing. Why? Because see, clearly you can see over here velocity will be something 10, 20 and over here it will be something 50. But over here dv by dt will be 0. Why? Because slope is 0 at this point. Means at this point acceleration will be 0. So from this point to this point acceleration is decreasing. Then only it will become 0 at this point. Clearly. Okay. So from this point just the opposite. Now this was the question asked in JEE Mains 2018. I want you people to answer this question. A, B, C. All the graphs below intend to represent the same motion. One of them does it incorrectly. Okay. Three graphs are representing the same motion. One of them does it incorrectly. Pick the odd one out. Pick the odd one out. So which one is basically not representing the motion of the others, like others? Tell me, which option is correct? Which option is correct? I'm waiting for your answers. Come on. Feeling too tired, man. Can you solo this? Oh, 1 second. Yeah, can you solo this? Which option is basically incorrect in all of these? Understand? Means three of the graphs over here are representing the same motion. One is not representing the like the other three are representing. A, definitely not, man. How A? See, A is basically saying that initially velocity is something, because velocity is having some positive value initially, fine. And after some time, velocity, not some time, after some, when body travels some position, for example, from this point to this point, velocity position graph. So it becomes zero. Understand? This travels from here to here. It becomes, velocity becomes zero. Understand? Then again, velocity becomes negative, because from this side, we basically say velocity is negative after some time, means body starts moving in the opposite direction. Fine. Now look at this graph. This is the position time graph. Initially, you tell me one thing. If you draw the slope tangent over here, slope is having some value. Definitely slope is having some value. If slope is having some value, that is ds by dt is slope at this point. It is what? Positive. Why positive? Because theta is less than 90 degrees. When theta is less than 90 degrees, in that case, slope is positive, means velocity is positive. Over here, velocity is positive initially, then becomes zero, then becomes negative. Initially, velocity is positive because slope is positive. Finally, after some time, velocity is zero. Why? Because over here, slope is zero. Slope is zero, because this is making theta is equal to 0 degrees with this one, tan theta 0. After some time, then velocity becomes negative. So this is exactly similar to this one. Moving on to this one. Now, initially velocity is positive. Then velocity becomes 0. Then velocity becomes negative. Exactly the similar. You tell me one thing. Distance time graph over here. Initially, you tell me the graph is like this. Slope is theta is equal to 0 because it starts from here. So from this to this, what is slope? That is 0. So distance time graph means speed is 0, magnitude of velocity. So means the car is initially at rest. So initially it is 0. Then after some time it starts increasing. Understand? And finally it again becomes, over here we say velocity 0. So velocity over here, that is positive. Just the opposite of these cases. So this is the odd one. Yeah. Come on. JEE Mains 2017. Can you solve this one? A ball is thrown vertically upwards. What is its velocity time graph? Ball is thrown vertically upwards. What will be its velocity time graph? See, we are throwing this ball vertically upwards, okay? So initially we give it some velocity. Means the velocity is initially, I would say, maximum, okay? Initially. Then it keeps on decreasing. At maximum height, top, it becomes 0. Then starts falling in the backward direction, in the opposite direction. Understand? So at here, velocity is 0. Then velocity becomes negative. This is the scenario you can use. Initially velocity is maximum. So this can definitely not be the case. Velocity is initially 0. Initially we give it some velocity. Now, is this the case? This can be, this can be, this can be. So initial condition is satisfied in all the three. Fine. Now, afterwards, velocity becomes 0. In this case, velocity is becoming 0. Velocity is becoming 0. Velocity is becoming 0. Afterwards, over here, velocity. Now, afterwards, velocity becomes negative. If you take this velocity as positive, this you have to take as negative. Because if you take the velocity in positive direction as positive, in left direction as negative. Same goes for this. You take this positive, downward direction as negative. So in this case, afterwards it's showing velocity positive. This cannot be one. This cannot be the one. Understand? So can this be the one? Definitely yes. And most importantly, you need to basically do one thing. See, you will say, sir, here also it is showing some velocity is positive, negative. See, in this case, we say acceleration is constant but a negative. Even if the ball is going in upward direction or is going in downward direction, we take acceleration as g, acceleration due to gravity. That is a constant and that is negative. We always take it negative, even if the ball is, because that's acting towards the center of the earth downwards. So we take it negative. In this case, what is basically the slope of velocity time graph? Slope of velocity time graph is acceleration. Means over here slope is negative, means acceleration is negative clearly. So when the ball goes up, acceleration is negative, satisfies the condition. Over here negative, negative, negative. Over here, so over here it becomes positive. Slope becomes positive, positive. This cannot be the one. This cannot be the one. This can be the one. Everybody understood this, man? Okay, come on, all of you. And do let me know in the live chat which states you are from exactly. Come on. Tell me the name of your states. So acceleration time graph, exactly the same case, okay? Body is moving in forward direction, I would say, okay, like this. At t is equal to 1, acceleration is 1. T is equal to acceleration is 2 meter per second square. Meter per second square. Meter per second square. Meter per second square, okay? Now, if I ask you to draw the acceleration time graph of this situation, you will simply say that is AT. So, at t is equal to 1, acceleration is 1. And t is equal to acceleration is 2, t is equal to 3, acceleration is 3, t is equal to 4, acceleration is 4. So this is the acceleration time graph of this situation. Understand, this is the acceleration time graph of this situation. Slope of acceleration time graph. So if I say this is theta over here, tell me slope. Slope of acceleration time graph is nothing but, we say that is delta A by delta t, because slope is nothing but that is tan of theta, is nothing but perpendicular by base. Perpendicular by base is delta A by delta t. Over here this is perpendicular. You will say this is A2, this is A1, this is T1, this is T2. So how much is this perpendicular? You will say, sir, A2 minus A1. You will say, sir, base T2 minus T1. That is nothing but delta A by delta t. Delta A by delta t. Okay, fine. Now this delta A by this delta t, we call this as, come on, we call this as nothing but jerk. You only know, sir, rate of change of displacement is velocity. Okay, rate of change of velocity is nothing but acceleration. Rate of change of acceleration is what? That is jerk. That is jerk. Understand? This jerk. So what is the unit of this jerk? What was the unit of acceleration? Meter per second square. So what is the unit of this jerk? It will be, for this it is meter per second square. So for this time it will be second. So it will be, unit of this jerk is nothing but meter per second cube. Yeah, I hope everybody is able to understand this one. Slope in case of acceleration time graph, I told you this. Slope in case of acceleration time graph, that is nothing but jerk. Okay, jerk. Now if I say, for example, the graph is something like this curve, tell me slope at a point. You will say, sir, we'll draw a tangent over here. If it is making theta, if it is making theta, we'll say at this point slope is nothing but, that is dv by, this is AT graph. It has to be AT graph. AT graph. It is nothing but dA by dt at this point exactly. So nothing but, that is jerk instantaneous. Okay, instantaneous jerk at a point. How fast acceleration is changing. Jerk is nothing but rate of change of acceleration. Now piece of gold. Guys, everybody is anybody feeling tired? Now see, what is this piece of gold? if we have, for example, this displacement, if I ask you to differentiate this one, you will say, sir, ds by dt. It is nothing but velocity. If you have this displacement, understand, if you have this velocity, if you differentiate this one dv by dt, it will give you acceleration. If you have this acceleration, dA by dt, if you differentiate this one, rate of change of acceleration, rate of change of displacement is velocity, rate of change of velocity is nothing but acceleration, rate of change of acceleration with time is nothing but, that is nothing but jerk. Now if you have this dj by dt, rate of change of jerk is nothing but, it is nothing but snap. Okay, remember all of these rate of changes. Okay, and if you have this snap, that is rate of change of this snap with time, understand, ds by dt, it is nothing but crackle. And if you have this crackle, that is a dc by dt, it means nothing but crackle, it means nothing but pop. Okay, fine. These are all the rate of changes. Understand, keep these in your mind because these are very important. Okay, this is not in your syllabus, still I'm saying you. So this is what we call the jerk is nothing but fourth derivative of position. This is snap fifth derivative of position. Understand, if you means that if you differentiate this displacement 4 times, you will get what? Jerk. If you differentiate this displacement 5 times, you will get what? Snap. Area under acceleration time graph. Like in case of velocity time graph, area under velocity time graph was giving us displacement. So here it will give us what? That is change in velocity. Now over here it is giving you the simple example of the real life example. Understand? A is 10 constant. This is this. If I ask you to tell me the change in velocity, how will you tell me in this case? You will simply say acceleration is nothing but that is dv by dt. Okay, take it over there. You will say, sir, dv is nothing but that is a dt. Now integrate this one, integrate this one. Understand, when you integrate this one, so what you will get, integration of this is nothing but delta v. Understand, so what is integration of this? A is basically nothing but that is constant from 0 to 5. It is saying from 0 to 5. If we basically acceleration, car is moving, acceleration is 10 meter per second square constant from 0 to 5 seconds. Tell me how much is the change in velocity. See, when there is acceleration means there is change in velocity. So you'll simply put that is 10 from 0 to 5 dt. Can you just tell me delta v is nothing but, take this out, it is nothing but integration of this dt from 0 to 5. So can I just write 10 multiplied by 5? It will be, because integration of dt is t, so it will come out to be nothing but 50 meter per second. So that is area under the acceleration time graph gives you the change in velocity, change in velocity. Now the acceleration time graph over here, if I ask you this is the acceleration time graph of this situation. Okay, fine. If I ask you to tell me the area under this acceleration time graph, you will simply say that is nothing but length multiplied by this breadth, length multiplied by this breadth. How much is the length? You will simply say length is nothing but from this point to this point. How much that is? If I say, for example, this is 5, so that is nothing but 5 into 10, it will come out to be 50. Means area under this acceleration time graph gives you what? Change in velocity, because this is 50, this came out to be the 50. Okay, everybody. Now, in case of a curved graph, over there, how to find area in case of a curved graph? We know area under acceleration time graph gives us change in velocity. Over here, how to find the area of this one? You take a single strip away, okay? You take a single strip. Now, if I ask you to tell me the area in this case, how you are supposed to find? You will say, we'll find the area of this one. Then we'll cut it in infinite number of strips, okay? These rectangular strips. We'll add all of those rectangular strips, area of all of those rectangular strips, we'll get the total area. So now, add the area of this one, add the area of this one, add the area of this one. All of these, so that is nothing but integration of dA. If I say area of this is dA, how do you find the integration of this one single strip? That is nothing but, if I say, for example, dA is nothing but how much? Over here, that is nothing but length into breadth. Length is how much? That is dt. If I say length is nothing but, that is a dt over here. Breadth, this length, breadth is dt, length is how much? That is, I would say that is a. So that is nothing but a dt. Now add all of those dh, it will give you the total area. So can you just write it is nothing but integration of a dt exactly. So this is nothing but integration of area under the acceleration time graph gives you the velocity. So it will give integration of dv is nothing but integration of a dt is nothing but integration of this dA area. From this point to this point, you can just put from A to B, you can put, or from T1 to T2, whatever it is. So it will give you eventually, that is delta V is nothing but integration of A dt from T1 to T2. Okay, fine. Same goes for this one. For this, can we say that is slope is 0? Means a dA by dt is 0. Understand? Why is slope 0? Because theta in this case is 0. So over here, slope is constant, uniform. In this case, means acceleration is in this case changing. Over here, acceleration is not changing. If this is A versus T, this is A versus T exactly. Okay, everybody understanding this? Okay. Now over here, can I say slope is nothing but negative? Slope is negative means jerk in this case is negative, because slope in case of acceleration time graph represents jerk. Over here, jerk is positive. We can clearly say because slope is positive. Now, this was the question asked in JEE Mains 2021 July shift. I want all of you to basically solve this question as soon as possible. If you can exactly solve this, come on. Which option is correct over here? The velocity time graph is given. You are supposed to find the acceleration time graph. Okay. That is what you are supposed to find exactly. Come on. Okay. We need to exactly. Oh. And guys, can you tell me what is the option, correct option over here? Come on. Tomorrow I'm going to start the new lesson. Somebody is saying, hi sir, looking handsome. I am, bro. Okay. Which option is the correct option? Option A, option B, option C. Come on. All of you. Option B. Definitely not. Definitely not. How you are supposed to solve this question? This was asked in recent. Okay. Before this, I want you people to tell me. Till now, you understood every bit I told you. Come on, in the live chat. Tell me yes or no. Now see. So, the velocity time graph is given. We are supposed to find its the acceleration time graph. How we are supposed to? Let me just show you. Okay, C, D are over here. Okay, this is the option number C. This is the option number D. Have a look. Have a look on C and D. Okay. See, can you tell me if this is the velocity time graph over here? Can you tell me the slope of this velocity time graph, or you just tell me the equation of this velocity time graph of this straight line? If this is a straight line, what is this equation of straight line? Y is equal to mx plus c. Okay, we say y is equal to mx plus c. It will be of this form only. Understand? Now over here, instead of this y, we have v. So I'll just put v. And what is m? M is slope. What is the slope of this line? You will say slope of this line, sir, that is nothing but perpendicular upon this base. Perpendicular is how much? 50 minus 10, that is 40. 40 upon this is 200, 0 to 200, 40 upon 200. So it will be 40 upon 200 into x plus c. At this, what is the intercept? That is this 10. That is this 10. Clear? This is the equation. So it will be nothing but, it will be x by 5. 40 into 5, that is this 200. Okay, so v is nothing but, can I just write this will be x by 5 plus 10 exactly. So this we got the equation of this line. Equation of this line. Clear? Equation of this line. Sir, lag gayi aaj. It is 8:27 and still I didn't finish. पूरी की पूरी. Okay, so this is the velocity time graph. Understand? This is the equation of this line. Understand? This is the equation of this line. We got this. Now if I ask you to tell me, we are supposed to find its acceleration time graph, means for that we are supposed to find the acceleration time equation first. Understand? The acceleration position equation first. Understand? Then only we can find its graph. Tell me, can we just write A is nothing but v dv by dx? I told you this equation initially. Now can we put, what is the velocity? That is x by this 5 plus this 10 instead of this velocity, and dv by dx means differentiation of this one. Differentiation. See, what is the method that I am exactly using over here is, see, we are giving this velocity x, okay? We are supposed to find its acceleration x graph. Now for that, we'll first find the equation of this one. Then we'll differentiate this one. We'll get the acceleration equation and accordingly we'll plot the graph then. That is the simple method that I am using right now over here. Okay, so v is this one that I got. And what is dv by dx? Accelerate. dv by dx of this one is nothing. For this, it is 0. Differentiation of this with respect to x. So for this, it is 0. For this, it will be how much? 1 by 5 only. So it will be nothing but 1 upon 5 only. Understand? Everybody? Come on. I need to know in the live chat if everybody is understanding this one. Now tell me, what will be the value of acceleration over here? Can I say acceleration is nothing but it will be what? It will be 5 2, it will be and x upon 25 plus this 2 exactly. Okay, plus this 2 exactly. All of you, can you tell me in the live chat you understood all of these concepts, whatever I told you? X plus, so we got this one. Means this, what is the equation? Finally we got x upon 25. This is the acceleration we got, plus 2 exactly. Fine, plus 2 exactly. Now the first case is when x is equal to 0. Now we'll plot the graph. When x is equal to 0 means, in this case, when x is equal to 0, let's see, when x is equal to 0, so how much will be the a? A will come out to be 2. A will come out to be 2. Means when x is equal to 0, a will come out to be 2. So this can be the graph, this can be the graph, because at this x is equal to 0, x is equal to 0, acceleration is 2, acceleration is 2. Because we are plotting this in the acceleration time equation only. So this can also be the graph, this can also be the graph. Let's go for the second one. That is, put acceleration is equal, put x is equal to 200. Let's see, because on 200 now we need to find. So put x is equal to 200. When we put x is equal to 200, how much it will come out to be? Acceleration will come out to be over here. It will be 200. It will come out to be only, that is 10. Yeah, acceleration will come out to be 10. Over here, when you put this 200 divided by 25 plus this, it will come out to 8 plus 2, that is come out to be, it will come out to be 10. So now what is the second graph? So this can be, it is 10. This can be the one, this is 10, this can be the one, this can be the one, this can be the one. Now the point over here is you have to use your brain, you have to use your mind. You tell me one thing. This is acceleration is y is equal to mx plus c. Y is equal to m 1 by 25. That is mx plus c. C is 2. Means this is the equation of straight line. Among all of these, which is the straight line? This can be the straight line. This can be, this is not the straight line. So this is not the correct option. This is not the correct option. So this can be the correct option. This can be the correct option. Now let's go for the another clue. Okay, let's go for the another clue. What is that? Now see, it is saying over here, velocity afterwards, velocity is what? Constant. Velocity is constant. Means acceleration is 0. Means we have to find that graph in which afterwards acceleration is 0. In this graph, is acceleration 0? This is acceleration x graph. In this, acceleration is 0. No, acceleration is having some value, 10, 10, 10, 10. In this graph, acceleration is 0. Definitely yes afterwards. So this is the correct option. How many of you people understood this one or any sort of confusion? I'll just repeat. This is the most important one. Come on. In the live chat, if you understood, drop a CC. Hey, Siva Ganesh, not D. It's A. In the live chat, if you understood this one, drop a CC. If not, then I'll make you understand this once again. Okay, first of all, this was the velocity time graph. We need to find its not velocity x graph, we need to find its acceleration x graph. Okay, now first of all, we found the equation of this one. We differentiated that one. We got the equation of acceleration. Then we saw this is coming out to be the straight line, so it has to be something like this straight line, not this or this, because this is having the straight line. Second clue, we got that when x is equal to 0, t is equal to 0. So exactly this and the first one was correct. Second clue was, in this case, it is clearly saying that acceleration is afterwards 0. So in this case, acceleration is 0. In this case, acceleration was not 0. That's why this is incorrect. That's why this graph is correct. Okay, let's move on to the next one. This was asked in JEE Means 2019. Tell me the answer of this graph. Tell me the answer of this question. Okay. Which of the three graphs represent same motion? ABC, ACD, ABD, CDB. Come on. Come on in the live chat, I'm waiting. ABC, which option? Which option is correct over here? Come on, I'm waiting for you. I'm feeling tired. C. Let's see. Which of the three graphs represent the same motion? In this case, acceleration is constant. Clearly, acceleration is constant. Time changing acceleration same. For example, 10 meter per second square, whatever it is. Acceleration constant. Straight line motion, acceleration constant. In this case, velocity is changing uniformly. Means if I find the slope of this one, that is acceleration. Slope is constant because at every point theta is same. So can I say over here acceleration is constant? Over here acceleration is positive. Over here acceleration is also positive because slope is positive. Theta is less than 90 degrees. In this case, S is equal to t square. S is equal to t square. So can you tell me what is the value of velocity over here? V is equal to ds by dt. That is nothing but 2t. Again, differentiate. Acceleration is a dv by dt. That is coming out to be 2 only. Means positive constant. So this representing same motion. Let's check for this one. Initially, it is having some velocity. Understand? Displacement time graph. It's having some velocity. Afterwards, velocity becomes 0. Acceleration 0. Because this is displacement time graph. Here velocity having, then afterwards it becomes 0. So definitely this is not exactly like all the three. So ABD option number B. Yeah. Not the 4. This third one, Khushi. GTA Rani is correct. A car starts from rest. Find the maximum velocity attained. Find the maximum velocity attained. Acceleration time graph is given. You are supposed to tell me maximum velocity attained. IIT JEE 2004. Okay. Now see, over here, we know that the area under the acceleration time graph gives us the change in velocity. First find that change in velocity. So that is change in velocity. Understand? Because previously I told you area under velocity time graph gives you the displacement. Area under acceleration time graph gives you change in velocity. So change in velocity. It is nothing but change in velocity is nothing but area under this graph. So that is 1/2 area of this triangle. That is 10 multiplied by 11. Base multiplied by into altitude. Understand? So 5, it is 55. So del V is coming out to be 55. 55. Now change in velocity, that is U minus V is 55. But it is saying that a car starts from rest, means initial velocity is 0. V minus U means initial velocity is 0. So V minus 0 is equal to 55 meter per second. Option D is correct one. IIT JEE 2005, its corresponding acceleration time graph. Velocity time graph is given. Its corresponding velocity x, this is x, okay? Velocity x graph is given. Its corresponding acceleration time graph. Its corresponding acceleration time graph. Come on. A, B, C, D. All of you in the live chat. A, B, C, D. Which option is correct? A, B, C, D, come on. Which option is correct? Come on. A, B, C, D. How you are supposed to solve this question? See, if we are supposed to find its acceleration time graph, let's check what is happening with the acceleration. Okay, check over here. See, could you please tell me first of all what is the slope in this case? You will say, sir, in this case slope is nothing but that is dv by dx, because this is v in terms of x. Okay, dv by dx, that is clearly negative. Why is slope negative? Because theta in this case is greater than 90 degrees. Theta in this case is less than 90 degrees. Okay, theta in this case is greater than 90 degrees, less than 180 degrees, sorry, 180 degrees. So clearly in this case slope will be negative. Okay, negative slope, and this is having velocity decreasing. Understand? Change in velocity in this case will be negative. So slope will be negative in this case clearly. Now we have studied the acceleration formula. A is equal to v dv by dx. Understand? Now a is equal to, use it over here in this graph. So v, velocity is having some value. So in this case, dv by dx is what? That is negative. So means whatever the acceleration in this case is, that is coming out to be negative. That will come out to be negative, because some value of velocity multiplied by negative, that will come out to be negative only. Now you will say, sir, if the velocity will be having negative value, that means negative into negative means positive. By over here, velocity is in the above the x-axis, so velocity has to be positive, because the graph is like that only, positive, positive, positive. From here only graph will start being negative. So graph is given from this point to this point only, so velocity will be positive for sure. So acceleration will come out to be negative. This is the first point. So in which of the following graphs acceleration is initially negative? Definitely not this one. Okay, this is acceleration time graph, not. So in this one it is 0. So in this one it is negative, in this one it is negative, in this one it is negative. Fine. Let's find the second clue. Let's find the second clue. Let's find the second clue. I want you people to answer me. Come on. Let's find the second clue. What is the second clue? See, it is saying that after some time, see, velocity keeps on decreasing. Over here, velocity becomes 0. if a velocity becomes zero, means acceleration also becomes zero. And a velocity zero, acceleration zero. In which of the graphs acceleration becomes zero after some time? Here velocity is negative, constant, not becoming zero. Negative, not becoming zero. In this case, clearly I can see that it is becoming zero after some time. So option A is the correct one. Initially negative, after some time it's becoming zero. Find average velocity, average acceleration from 0 to 20 seconds. Average acceleration from 0 to 20 seconds. Okay. Find average acceleration from 0 to 20 seconds. You will say, how do we are supposed to find? Average acceleration is what? AVG is nothing but delta V by delta T. Okay. Now in this case, how you are supposed to find the delta V? This is a acceleration time graph. This is not the velocity time graph. Okay. In this case, how you are supposed to find the delta V? That is area under the acceleration time graph gives you the change in velocity. I told you. So area under acceleration time graph gives you the change in velocity in case of acceleration time graph. That is area of this triangle 1 by 2 base into altitude. That is 20 multiplied by this 20 multiplied by this 10 plus this area of this one, that is 20 multiplied by this 10. Put it over here, and a change in time is a 20 minus 0. Put it over there, get the answer. That will be your answer. Let's move on to the next one. Same goes for this one. Use the same method for this one as well. Particle is thrown upwards. Find its acceleration time graph, velocity time graph, and displacement time graph. Now see, previously I told you, if we throw the particle in upward direction, okay, if we throw the particle in upward direction, initially velocity is basically maximum. At this point, velocity becomes zero. At this point, velocity becomes zero. And then it falls back, velocity with negative velocity. Now you tell me one thing, in this graph, which is clearly representing that, is this the velocity? This is the acceleration time graph. Okay, if we throw the body in upward direction, we take acceleration as g, that is constant, and acceleration as negative. Understand? We take this g always constant, always negative. So which one is over here? Acceleration is positive, not this one, not this one. Okay. Is it this is the graph over here. Sorry. Acceleration is constant negative, so definitely this one. Constant negative. Understand? Negative constant. So acceleration is negative over here. And in this case, definitely not this one. Acceleration is changing. Jerk will be constant in this case. Definitely not this one. It's velocity time graph. I told you previously, velocity keeps on, initially velocity is maximum, keeps on decreasing, becomes zero. This one. So not this one, not this one. Over here, velocity is constant, negative constant, not this one. It's a displacement time graph. It's displacement time graph. Understand? We say basically in case of displacement time graph, its acceleration has to be what? Negative. Its acceleration has to be constant. In which of the graphs acceleration is negative and constant? In this case, acceleration is constant but positive constant. So this cannot be the one. This cannot be the one. In this case, acceleration is zero. This cannot be the one. So clearly this is one. This is just the opposite of this one. Here acceleration is negative. Acceleration is constant. Equations of motion. Come on. Yeah, that's great. Okay, all of you be attentive, man. After this, we need to find this some equations of motion and we are done. And then we have motion under gravity. I was expecting only 2 hours for this session. It took so long, man. How many of you are feeling actually tired? Come on, do let me know in the comments. Do let me know in the live chat down below. Okay. Okay, it's 8:46. It's 8:46. Let's basically take a break till we'll take a break till 8:55. Okay, 8:55. Yeah. Let's basically take a break till 8:55. Till then, we'll have a conversation, a great conversation, okay? We'll have to finish it by today itself, okay? It's just one shot, okay? It'll not take much time. I'll finish it in next. Now the problems will come, some good problems will come. Okay, it'll just finish in next 10, 30 minutes. I'll finish till 9:30. I'll cover it, okay? Anything else you want to ask me? Not from the studies, okay? Because so tired right now. because because of my hair, bro. Okay, tomorrow I'll make the hair like that only. Chill scenes. Oh man, I'm feeling too tired. One second, I'll just play this blue over here so that you'll be able to see me properly. Yeah, it's fine now. It's more fine now. Oh man. Okay. So guys, everybody is basically speaking English over here. Anybody who speaks Hindi as well? Or everyone is from? So most probably we'll do the one shot of calculus tomorrow, okay? Because a lot of people keep saying me, sir, please one shot of calculus, one shot of calculus. So we'll be talking about that by tomorrow, most probably, okay? Tomorrow we'll have my cousin, very small cousin, is outside. She's crying. Okay, if you can hear that. Yes, yes. Ria, are you the same Ria who come in my special classes? Are you the same Ria? I am from Kashmir, bro. The most beautiful place on earth, the heavens on earth. Okay. Okay, that's great. You guys understood everything whatever I told you today? Yes, I do remember. Ria, Rachel, non-veg. Sir, you and Wasim sir are brothers, sir. Yes, we are brothers. Okay. Yes, 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 bro. I was for 4 years in Tamil Nadu, okay? Do you know Potteri, Kattankalodar, Chennai Central, everything, bro? Okay. Hmm. Sir, and me, do you remember? No, 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 no. Definitely not. You're from some other planet, okay? Alien, I guess. Your board teaching is same, sir. Okay, okay. I'm already done with 2 liters of water, huh? Okay, I just want to know how many of you are watching from mobile phone and how many of you are watching from laptop? Uh-huh. Ellenite. Come on, in the live chat. I just need to know, man. Great, great, great. I got a laptop in my back top. Okay, that's great. Okay, how many of you are taking notes exactly right now? Come on, how many of you are taking notes right now? I'm not asking you the brand name, bro. You're telling me Dell One Plus. Okay. Ah, that's great. Try to make the notes of every single lecture, okay? It'll definitely help you. Hmm. Samsung J2. Okay. That's great. That's great. J2 still working, bro? Very old model. Okay, guys, the chemistry class has been postponed. You don't have chemistry today, okay? So chill scenes, you don't have chemistry today. No, 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 no. One second, I need to check it. Live in 24 hours, 2 days. Yeah, you don't have the chemistry class today. That has been postponed already. So chill scenes will continue. Yeah, 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 yeah. Yeah, we'll just continue. Just 2 more minutes, bro. Okay. No chemistry class today. Okay, okay, that's great. We'll be focusing on most probably the projectile motion as well, or some other portion from the modern physics. Let's see what happens. We'll start exactly at 9 o'clock, okay? 3 minutes left. 3 minutes left. Okay, okay, okay. You guys done with the dinner or not yet? That's great. I'm not, definitely. Only, I drink only while I take class, okay? Not the other time. And when I am in gym, exactly. Otherwise, I don't. Na, na, na. So we need to basically start now once again. People. Yeah, it's good to drink more and more water. Okay. Fine, fine, fine. Okay, shall we start? Sir, one day. Yes, 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 we'll do it. We'll do it. We'll do it all together. Chill scenes. Okay. Chalo, let's get started. Let's get started once again. Okay. Let's get started, guys. Okay. Now, see, we'll now talk about the equations of motion. What actually these equations of motion are. Okay. Let me just give you the today feel. Now, if I say, for example, you are traveling from this point to this point, your acceleration is 10 meter per second square. This is constant. Meter per second square is constant. Okay, this is constant. Traveling from this point to this point, 5 seconds you are taking. I'm asking you at this point, when you reach this point B, how much is your final velocity? You'll say, sir, it's very easy. We can easily solve this. So acceleration is nothing but dv by dt. Take it over there. So dv is nothing but a dt. Understand? So this is integration. Integration of this is what? That is a delta v, clearly is nothing but what? Integration of a dt from 0 to 5 seconds, from 0 to 5 seconds. Okay, so integration of 0 to 5 seconds, how much is acceleration? That is 10 dt, clearly. So delta v, that is v minus u, clearly we can say it like that, or simply you can just keep it like this. Okay, so it will be nothing but 10, and this will be this will be simply t and from 0 to 5. Further, we can simplify this. Okay, starts from rest, u is 0. So v is equal to, this will be nothing but put the value of t as 5 first, then 0. 5 into 10, that is 50. So it will come out to be 50 meter per second. Fine. You got this. You got this. Yeah. You got this velocity, final velocity. Now, I'll tell you a trick. That's a good trick, not that good. So v is equal to u plus at. If I have this equation, this is a proper equation that I have. Now, I'll use the same equation and I'll get the answer in just one step. So v is final velocity I'm supposed to find. Initial velocity saying started from 0. This car started from rest. So this is 0. Plus acceleration is how much? That is 10. So this will be 10. Time is how much? Taking 5 seconds. That's 5. It is 0. This is 10 into 5 into 10. That is 50 meter per second. I don't have to do this stuff. Directly I got the answer just in one equation. Okay. What is this? It gave me the answer just in one step. Okay. So this is the equation, but not the actual equation of motion. I'll make you understand. I'll make you understand. So where does it come from? It comes from here only. So before that, I need to give you the feel. Okay. Now, have a look on actual equations of motion. Okay, fine. Now see, what are the actual equations of motion? See, this is the equation we used in this case when the acceleration was constant. If the acceleration is not constant, you cannot use this equation. You cannot use this equation like v is equal to u plus at, s is equal to ut plus half of at square, or the other one, v square minus u square is equal to as. You cannot use these equations until and unless the acceleration is not constant. Now see, we say actual equations of motion which you can use any time, even if the acceleration is constant or not constant. What are those? We say s is equal to, if you are given the displacement, okay, the car is traveling from this point to this point, displacement is changing. I'm asking you to tell me the velocity over here. You will simply say, sir, v is nothing but rate of change of displacement with time. This will give you the velocity over here. This is the golden equation. This is the actual equation of motion. Understand? That is when acceleration is constant. What is acceleration? That is nothing but, sir, dv by dt. This is how you are supposed to find the acceleration as well, when velocity is given or when velocity is basically changing. Okay. Now, there was another equation as well, that is a v dv by dx. How does this come? This basically, when you multiply dx by dx over here, then you get this one exactly. Understand? So these are the actual equations of motion. Now, the other equations of motion actually are, now if you see here, if a displacement is given, velocity you are supposed to find, you differentiate. If a velocity is given, you are supposed to find acceleration, you differentiate. If this a displacement or velocity, something like that is given, you are supposed to find acceleration, you do this stuff. Now, if you are supposed to find displacement from velocity, in that case, what do? That is nothing but v is equal to ds by dt. Take it over there. So what you will do? So that is a ds is equal to v dt, integration. So s is equal to v dt, integration of ds, small ds, it will give you total displacement integration. So in that case, you do this stuff, you do integration, the reverse process. This is the golden equation of motion. This is the actual equation of motion. Either we'll take calculus tomorrow or projectile motion. Okay. So now see, and if, for example, velocity is, if acceleration is given, you are supposed to find the change in velocity or velocity something, you do integration again. So can we just say delta v is nothing but integration of a dt. So these equations are actual, the golden equations. Understand? This you can use any damn time, even if the acceleration is not constant, you can use all of these equations. Now, what are the equations that you can use only when acceleration is constant? V is equal to u plus at, s is equal to ut plus half of at square, and the other one as well. Where does those come from? Let me just tell you. If I say, for example, a is equal to, that is nothing but dv by dt. This car is traveling from this point to this point. I'm asking you, acceleration in this case is constant. Condition. At this point, tell me the velocity. Take this over there. So dv is nothing but a dt. Now integrate this. We are supposed to find the velocity. Acceleration is given. So integration stuff we do. So this is nothing but delta v integration of a dt. Understand? So this is nothing but delta V, that is u minus v. Sorry, v minus u, final velocity minus initial velocity. v2 minus v1. So that is v minus u. Okay, and integration. I'm saying acceleration is constant. Take this out. Acceleration is a integration of a dt. So can I say v minus u is nothing but a integration of dt is nothing but that is a t only. T only. From where to where? From 0 to t. Put the limits also from 0 to t. 0 to t. 0 to t. It will be only ut. So v minus u. Arey yaar. U minus v. U minus v. V minus u is equal to a into t. V is equal to u plus at. So we got this equation from this only. Understand? We got this equation from this only. But when we took this acceleration as constant, when this acceleration is constant, we took this out, then only we got this equation. If acceleration is not constant, we will not get this equation. That's why we can use this equation only and only if acceleration is constant. Let's derive the another equation as well. Now, that is the second equation. Can we say v is equal to, that is a ds by dt. Now, from this point to this point, car is traveling. I'm asking you to tell me the displacement s. How much displacement it has traveled? Acceleration is constant. So take this over there. So ds is equal to v dt. Now integrate. From where to where? From 0 to s. From 0 to s. From u to v. For example, initially I am saying velocity is u. Finally, if I am saying velocity is v. Fine. Now tell me in this case, so can I just write it is nothing but integration of ds will be nothing but s. Integration of ds will be nothing but, this will be nothing but s from 0 to s exactly. And v, previously we got this one, put this over there. It will be integration of u plus a t from u to v, and it will be nothing but a dt. Now, so it will be s minus 0, that is nothing but s only. Understand? So it will be, now integrate this with respect to t. So can I just write, if we integrate this one, it will be ut, and this will be plus a, and this will be t square by 2. T square by 2 exactly, and from 0 to, it was exact with respect to t. It shouldn't be basically u to v. Sorry, my bad. 0 to t, because we are integrating it with respect to t. So from 0 to t, exactly. Sorry, from 0 to t. So can I just write, it will be nothing but ut. When you put the limits over here, it will be ut plus 1 by 2 at square only. So this is the second equation of motion. We got this when we took this acceleration as constant, then only. Come on. Everybody understood this one? Any confusion in this one? Let's go for the equation number 3. A is equal to v dv by ds. Take it over there. So a ds is equal to v dv. Just deriving these equations with the speed of light. Okay, now integrate this from this one. Okay. From 0 to s, okay, if the car is traveling from this point to this point, acceleration is constant, initial velocity is u, final velocity is v, okay. Now, so it will be nothing but a, and it will be a is constant, take this out. That's why over here a is constant, take this out. So it will be integration of 0 to s, integration of this ds is nothing but integration of this v dt from u to v. Initial velocity is u, final velocity is v, okay. So it will be nothing but integration of u to v, v dv is not, this is v dv. Now do it over here. So a, it is nothing but s from 0 to s is nothing but, this will be v square by 2 exactly from u to v. So as is nothing but, this will be 1 by 2, or simply v square by 2 minus u square by 2. So it will be v square minus u square is equal to, you take this 2 over here to as. Just the simple mathematics I am doing over here. Just the simple mathematics that I am doing over here, okay? No need to confuse yourself. So v square minus u square is equal to 2as. Third equation also when we took the acceleration as constant. Yeah, show some Josh in the chat. Everybody understood this? Come on. So this is the equation, second, third, not the actual equations of motion, okay? Actual equations are those only. Now the car is moving with 10 meters per second. Velocity after 2 seconds, after 3 seconds starts from rest. Come on. Can you tell me v is equal to u plus at after 2 seconds, you need to find the velocity. So V is equal, initial velocity starts from rest, 0 plus acceleration 10 meter per second. That is after 2 seconds, it is 20 meter per second. Same, in order to find displacement, use S is equal to UT plus half of AT square. Come on. Now, the question, this one, this was asked in some JEE 2003. Previously, I have showed you this also. JEE 2003. Come on, can you solve this question? Do let me know A, B, C, D. Do let me know A, B, C, D. Okay. Which option is correct over here? Come on. Which option is correct? Come on, in the live chat, all of you. Okay. Now see how we are supposed to see. A car is moving with a 50 kilometer per hour, applied brakes and stops after 6 minutes. After 6 minutes it stops. Okay, so this car is moving with 50 kilometer per hour. It applied brakes, after 6 minutes it stops. Okay, another car, this is a case of constant acceleration, both are having same acceleration. So another car that is moving with 100 kilometer per hour, applied brakes, we are supposed to find after what distance it will stop. This stops after 6 minutes. After what distance this car is gonna stop, that we are supposed to find in this case. So very easy and simple question. For the first case, use the equation. For the second case, use the equation. As acceleration is constant, equate both of these. Question khalas. Okay, let me just show you. For the first one, use the equation, that is V square minus U square is equal to 2AS. Okay, how much is V square? It says that initially moving with 50 kilometer per hour, applied brakes, means afterwards it stops at 60 kilometer per hour at 6 minutes. So that is 0 square minus 50 square, it was moving initially, is equal to 2 into A, acceleration I would say A, and stops at what distance? That is 6 meters, it is 6. So equation 1. Let's create the equation 2 for the case number 2. Now, V square minus U square. So over here, it is moving with a velocity of 100 kilometer per hour. So finally it stops. So that is 0 square minus 100 square is equal to 2A. What is the value of S in this case? That we are supposed to find exactly. Now, can you find the acceleration over here? You will say, sir, simply acceleration is nothing but minus 50 square upon 2 into 6. Over here, acceleration is, sir, that is minus 100 square upon 2 into this S. Okay. Now, acceleration, equate both of these, get the answer. Over here, that is minus 50 square. So I'll just write it like this. It'll be minus 50 into 50 upon 2 into 6 is equal to minus 100 into 100 upon 2 into S. Is this upon 2 into S? Yeah, exactly. So this 51s, 52s, 51s, 52s, 2 to 4, and this also will get cancelled off. So S will come out to be 24 meters. So which option is correct? Option C is the correct option. Okay, option C is the correct option. Fine, all of you, you got it, you got it. Come on, man, I just want to know in the live chat. I just need to know in the live chat. So JEE Mains 2020, this is actually the question of relative motion. Okay, this is actually the question of a relative motion. Okay, fine. Now see what happens over here. So this is actually the question of relative motion. It says that a car standing 200 meters behind a bus. Okay, this bus is moving. Okay, starts at rest, starts from rest, moving, and there is a car over here. Okay, there is a car over here. Okay, such that the distance between these two is basically 200 meters, which is also at rest. Okay, the two started moving at the same instant but different accelerations. Okay, so this is having the acceleration of 4 meter per second square. This is having the acceleration of 2 meter per second square. And the car will catch up the bus after a time of, this car will basically catch this bus after what time? that we are supposed to find. Exactly. So they have this difference over here. Yeah, the guy is saying, Siva is saying C. That's nice. Now let's see. So over here, first of all, you just use the equation from this point to this point. That means you just use in case of a relative motion over here. I'll tell you this relative motion in kinematics study. Don't worry about that. Okay. Chill scenes, buddy. Okay. Now, in this case over here, can we say in this case over here, this was kinematics 1D what? One shot. Okay. Now, okay, fine. Now, in this case, can we basically say it like that? How much is the relative acceleration? You will say, sir, this is having the acceleration of, according to this, this is having the acceleration of 4, this is having the 2. So how much is the relative acceleration? You will say 4 minus 2 is 2 meter per second square. That's all. So now S is equal to ut plus half of at square, ut plus half of at square. Over here, what is the difference between these two? That is 200. Ut, both started initially from rest. Forget about that. This will be 0. 1 by 2. Acceleration is how much? That is relative. That is 2 only. T is we are supposed to find. So over here, this root, this 2 will get cancelled off. T is nothing but root of 200. T will be nothing but 10 root 2 seconds. C option. Okay, this is a good question. I want you to solve this question. I need you people to tell me. Who is this guy? Kisan Ekta Zindabad. Okay, come on. I want you to tell me over here, a bullet is entering a wooden plank with a velocity v. As it loses its 1 by nth of the original velocity. The width of the planks is S. Okay, the width of the plank is S. How many planks are required to get the bullet at rest? Now see, what is the question that exactly explaining over here? See, we say, for example, this is the plank. Okay, this is a wooden plank. The bullet is entering this wooden plank. Okay, for example, initially it is having the velocity v. Afterwards, it loses 1 by nth of its velocity from its original velocity. Okay, so can I say afterwards its velocity becomes v minus v by n, 100%. Okay, it is saying that how many planks we need to basically put one after another so that the bullet will come to rest. If I say I'll place the planks over here, over here, over here, exactly. Okay, exactly. So how many we should place these one after another so that the bullet should come to rest? I would say, for example, we need to place x planks. We need to find the value of this x planks. That's all. We are done with the question. Okay, now see. In this question, use the equation from this in the first case. Understand, for the first plank, if I say the distance of this plank is, the width of this plank is S, that's given in the question, and then use the equation for all of the planks, you will get the answer for sure. This is the approach that we should basically use in this one. Now see, if I say, for example, from this point to this point, first of all, we'll use the equation in this first plank only. Now, which equation? That is v square minus u square is equal to 2as. Clearly we can say it like that, definitely. Now what is the final velocity in this case? If we use it for first plank only, initially it is moving with the velocity u, v, then it loses 1 by nth of its original velocity, v minus v by n. So can I say final velocity is v minus v by n, its square, minus initial velocity, that is u, v square, is equal to 2as, equation number 1. Fine. Now use the equation for the whole of the planks. That will be v square. What is v square? Final velocity. It says that bullet will come to rest. How many planks we need to place? So final velocity will be 0 minus initial velocity when the bullet is entering, that is v square, is equal to 2as. S, and I'll put the x over here because we need to find how many planks. S is for one plank. How many planks? I am saying x. So s, x, exactly. These are the two equations. Just divide this with this. You will get the answer. Let me show you it over here. So it will be nothing but minus v square upon, we'll divide this with this. v minus v by n square, v minus v by n square minus v square, exactly it will be equal to 2asx, 2asx upon 2as. This is what we are supposed to do over here. Everybody understanding? Come on. So this will get cancelled off over here, and I'll cancel this v square. Okay, this. Okay, if I take this common, I can cancel out this one also, and this will be minus 1 upon 1 minus 1 by n whole square minus 1 square, exactly. Fine, and it will be equal to x. Now elongate this a minus b whole square. So minus 1 upon, it will be nothing but 1 square minus plus 1 by n square, okay, a square plus b square minus 2ab, that is 2a, a is 1, b is nothing but 1 by n, means 2 by n, and then this 1, exactly, minus 1, it will be equal to x. Further simplification, what we can do over here is, so this and this will get cancelled off. So multiply this with this one. Can we just multiply it? Exactly. So it will be nothing but, this is n minus 2n square. So this is n minus 2n square upon this n cube, and this will be minus 1. It will be equal to x. What else can we do over here? Okay, 2n square. Am I going in the right direction? 2ab. Yeah, exactly. 2n square, 1 minus 2n square. It will go n cube. Okay. So can I just write this exactly? It will be something like x will be equals to, if I take this n cube over there, and it will be n minus 2n square. Okay, n minus 2n square over here. So it will become, if I take this n common, so it will be n. If I cancel, this will be n square upon, this will be 1 minus 2n. Exactly. Is this the option? 1 minus 2n, n square upon 1 minus 2n, n square upon 1 minus 2n, n square upon 1 minus 2n. Exactly. So is this, no, we made a mistake somewhere. Guys, where exactly? Let me just erase it from here only. Let's solve this once again. Let's see what happened exactly. Okay. So let's solve this once again. Let's see what is gonna be the answer. Everybody, see, basically the point over here is, before I solve it, you have to solve it this, and do let me know where exactly I have made this mistake. So we'll go for the solution once again. All of you, come on, in the live chat itself, I need to know. That's why I keep saying you every single time that you have to solve this before I do it. Come on. N square, yeah, n square minus 1, exactly. We need to go for this one. Let's see. Okay, let's go for this one first. So this will be nothing but, it is this is minus 1 upon, can I just write, this is 1 minus 1 by n, this is whole square minus 1, exactly, and it will be nothing but x. And we can just take it, it will be minus 1 upon, this will be 1 square plus 1 by, yeah, exactly, 1 square upon 1 by n square, okay, 1 by n square, and then it will be minus 2 by n, and then 1 minus 1, exactly, it will be x. Now it will come out to be exactly the same. Okay, it will come out to be exactly the same. All of you found this one day. Come on. Two by n. So can we just write it afterwards? Exactly, it should be like this only. So x is nothing but minus 1 upon 1 plus 1 by n square minus 2 by n only, because this and this will get cancelled off. Okay, all of you, can we just write it like that? So further, okay, this will get cancelled with this one. Okay, this will get cancelled with this one. Now afterwards, what we are supposed to do is that is cross multiply this over here. What we're gonna get exactly, can we just write this will be minus 1 upon 1 minus 2n by this n square. Okay, and you need to take this n square over there now exactly, and you will get, so this will be x is nothing but, because n square, see, this is when we basically multiply this one n with this 2n square, and then n will take common and this will be n cube, n square, and 1n will get cancelled with this one, so it will be nothing but over here, it will be nothing but yeah, exactly, so it will be nothing but n square minus n square over there, 1 minus 2n exactly. अरे यार हमने ठीक किया था. So it will be 1 minus 2n exactly. So can I just write x is nothing but, if you interchange this one, what is the option? Yeah. If you interchange this one, you n square by 2n minus 1, because interchanging this one, it will get to 2n minus 1, 2n square. If this is correct, 2n square, 2n minus 1, n square upon 2n minus 1. Yeah, n square upon 2n minus 1. So this is the correct option. I guess option number B is matching with this one. Come on, in the live chat. Okay, you got this one? We actually made the mistake over here only at the last step previously. So, okay, so what you are supposed to do is interchange this one, then cancel the negative, and you will get the answer exactly. That is correct. Fine, let's go with the next question. So now we have this vertical motion over here. All of you, come on. Now, vertical motion. What is this vertical motion all about? See, previously we were talking about the horizontal motions. The car is traveling from this point to this point. Understand? Fine. So we say this is moving horizontally. And in that case, we were finding its velocity, acceleration. We were finding lot of equations we derived, every stuff we derived. Now the case is, if we take the same box and if I release, everybody, don't look at the chat right now. Don't spam over there. Look at me. We'll finish this afterwards. We'll have a great conversation, okay? Take this block and release it. Understand? If you take this block and if you release it, it will basically fall down. It is motion under gravity. If this is you call the horizontal motion, can we say this is vertical motion? Because this is vertically falling. This is doing the motion in a vertical direction. This is vertically going downwards, okay? This is vertically going downwards. Can I say definitely it is like that? Come on, all of you. So this is what we call the vertical motion, or this is what we call the motion under gravity as well. Understand? Because it's under gravity. Gravity is pulling it towards itself. So that's why we call it the motion under gravity. And see, there is the one common example, beautiful example, that is the throwing the ball in upward direction, then it comes back. Now, there are some things we need to exactly see. We need to basically talk about its velocity, analysis of the velocity. Okay, like you were talking about the velocity when the body was moving in the horizontal direction, acceleration, its displacement and all. Now, let's talk about the velocity over here. I told you previously also, when we throw the ball in upward direction, when it goes up, and initially we say velocity is maximum. Understand? When it goes up and it reaches the maximum height over there, okay, over there, we say velocity is basically zero. We say velocity is basically zero at the top. Initially, velocity is maximum. It keeps on decreasing because gravity is pulling towards itself. So velocity keeps on decreasing. At the top, it becomes zero. Then it starts falling in the opposite direction and starts increasing the velocity once again. So the velocity at this point will become zero. When the velocity will reach same point over here, velocity will have same magnitude, that is minus u. If we throw it with the u velocity, it will have same but in opposite direction. Understand? So what happens with the velocity? Initially it is maximum, then becomes zero, then again becomes maximum. Understand? In the opposite direction. So initially we say velocity is positive, positive. When we throw the ball in upward direction, then velocity becomes 0, then velocity becomes negative. This happens with the velocity. Moving on to the acceleration. In this case, we always say acceleration is nothing but g. We take this g as constant, that is acceleration due to gravity. Understand, this is motion under gravity. So we say this is 9.8 meter per second, meter per second square. Okay, so we say this acceleration always we take as negative, minus g. Even if the body is going in upward direction, body is falling back, in that case also we take acceleration as a negative only. Now displacement, distance. If the body goes up and comes back, it is the original point and the final point are same. We say displacement is nothing but 0, and distance is how much? That is 2h. Body goes up. If I say body has covered the h height, then comes back with the same h height. So distance is what? Distance is nothing but 2h. Displacement is 0 because the body hasn't displaced. It will come back to its same point only. Take acceleration g. Now, if acceleration is constant, if you say acceleration is basically constant over here, so can you use all of these equations? Definitely yes. V is equal to u plus at, half at square. This, all the three equations definitely you can use because acceleration is constant. We can use these equations only and only when acceleration is constant. Fine. Now, point is, what if I ask you to tell me the maximum height attained? What if I ask you to tell me the time taken to complete the vertical motion, distance, displacement, velocity with which it returns? Okay, this is what we are supposed to find. Afterwards, we'll solve some of the previous year questions as well. Then we are exactly done with this topic. Okay, this is the case that we need to exactly follow in this one. Fine. This is the stuff that we need to exactly use in this one that we need to do. So when we throw the ball in upward direction, we need to basically find the maximum height and gain. How much high it can go. Time taken, how much time it's going to take to complete this motion. Displacement covered, distance covered, velocity with which it returns. And let's talk about all of these. So we say this time is nothing but 2u by g simply. Okay, v is equal to u plus at. Time of ascent is u plus g. Time of ascent, that is equal to u by g. And the time of descent, how much time it's gonna take to reach this height, that is t1. T2 is basically how much time it's gonna take to come back, that is u by g. Total is 2u by g. Okay, in direct method we can basically, that you can find basically v is equal to u plus at. In direct method you can basically use it like this, you can find it like this. So s is basically how much? You say displacement is how much? That is 0 simply. U into t. T is how much? T is what? T is the total time taken. Why is displacement 0? Because when the ball goes up and comes back to the same point, so displacement is obviously 0. So ut plus half of at square, and we take this as negative. We take this as a negative. Why negative? Because acceleration we take as negative g. That's why it is negative over here. T square, exactly. Take it over there. So it will be ut is equal to nothing but 1 by 2 gt square, exactly. Okay, fine. So can we find this t square? T and square will get cancelled off. T is nothing but 2u by g, exactly. Previously what it was, 2u by g. Now it we got. So total time is basically 2u by g. If I say t1 is u by g, t2 is u by g. All of you understood this? Come on, in the live chat. Yeah, come on. Yeah, height is this one. Height is this one. Yeah, exactly. Now, how much is the maximum height attained? How much is the maximum height attained? How much is the maximum height attained? Can you tell me? U square by g that you told me. Okay, so S, we'll use this equation. Can I say, for example, this is what? H. Height attained is h. We're using this equation from this point to this point only. From this point to this point only. Keep that thing in your mind. Previously, we used this equation from this point and back again till here. Understand? Now, SH is nothing but initially that is ut over here plus 1 by 2 minus 1 by 2. Why minus 1 by 2? Because acceleration we need to take over here, that is negative, and this will be gt square, obviously. Okay, now you tell me one thing. Can I just write h is equal to u? T, how much time it is taking from this point to this point? U by g. In completion, 2u by g. So can I just write that is u by g over here minus 1 by 2 g into u square by g square. Exactly, this will get cancelled off. And what else I will get over here? So h will be nothing but that is u square by g minus 1 by 2 u square by g. Fine. So this is u square by g minus 1 by 2 u square by g. Means you are subtracting half from the full. Understand? This is 1 minus half. So it will be what? It will be half only, because u square by g minus half of u square by g. So it will be nothing but h is equal to 1 by 2 u square by g only, that is u square by 2g. Fine. So this much height it is going to attain in this case. Yeah, exactly. Now, so you can basically use this one also in order to find that return velocity. With what return velocity it's gonna basically come? Okay, what will be the return velocity that we gonna need? We're gonna find in this case right now. That is what we are supposed to find. Okay, now you tell me one thing. We are launching this ball from here to here, it is coming back. Okay, now use the equation from this point to this point, because we need to find the velocity at this point. Okay, finally, what is the velocity with which it is returning? We're throwing the ball in upward direction, it is coming back. With what velocity it will return, that we are supposed to find in that case. Okay, so can I say this height in that case is basically nothing but this one? Okay, this is displacement. We need to find the displacement afterwards. Okay, this is basically the return velocity. Okay, this is the return velocity. This is displacement and this is return velocity. Okay, use the velocity equation from this point to this point, understand, in order to find the velocity at this point. Exactly. So can I say that is final velocity that I am supposed to find, that is v square minus what is initial velocity over here? Initially, when the ball starts leaving the maximum height, over here velocity is 0, means initial velocity is 0 is nothing but 2g, and this is h. Acceleration, instead of this acceleration is minus 2g, and instead of this s I am writing h, because if I say, for example, this height is h, so it will be nothing but v square is nothing but minus 2g h. So what is the height previously we got? V square is equal to minus 2g, and this, how much is height exactly? From this point to this point we got previously, how much was that height? That is nothing but u square by 2g. This will get cancelled off. 2g will get cancelled off. V square is nothing but minus u square. So can I say v is equal to minus u? Exactly. Yeah. So means if you are launching this with a velocity u, finally it will come back over here. It will have same velocity over here, but in the opposite direction, minus u. Magnitude will be same, but direction will be opposite. That's why negative. Come on. In the live chat, can you tell me if you are understanding this properly? Any confusion? If there is any confusion, I'll repeat it. Okay. So displacement traveled. Can you tell me how much is the displacement traveled from this point to this point? Obviously, it has to be 0. So we need to find, this is u into t minus 1 by 2 g into t square. How much is the time from this point to this point? Exactly. You will say that is nothing but u into, that is 2u by g minus 1 by 2g into 2u by g. It is nothing but 4u square, because it is t square, that is 4u square by g square. This will get cancelled off. 2 1s, 2 2s. So it will be nothing but s is equal to 2u square by g minus this 2u square by g. So 2u square by g minus 2u square by g, it is 0. That's why I told you displacement has to be 0. Displacement has to be 0. Displacement will be 0 because it will return back to its original point. That's why. So distance traveled, it's obviously, if it goes till here, it will cover h. If it comes back, it will cover the same h. So h plus h, that is 2h. That's why I told you 2h. So what was the h? That is u square by 2g. Now it is this. So displacement will be, distance will be nothing but u square by g. Exactly. Come on, all of you. These are the basic things. Now special case, free fall. Okay, if the block is basically falling, in this case, we are supposed to find this one. Can you tell me if the block is this falling, if the block is this falling, if the block is falling, how much time it's going to take to reach the ground? In that case, how we are supposed to find this one? Okay, So use this simply in order to calculate that how much time it's going to take to reach the ground. So if I say this S is nothing but, can I say this is minus h when you travel from this point to this point? For example, if I'm saying that you take this as minus h because it has traveled h height. Now, if you take this as origin, initial point, this is final point. From the origin, how much you have displaced? Minus h, understand? That's why I'm asking you to take this minus h. It is nothing but initial velocity. Initial velocity is 0 over here because we are releasing this, understand? Means initially it is at 0 velocity, we release. So this will be 0 and this will be minus 1 by 2, minus 1 by 2. Instead of this acceleration, that is g, and this t, can we put the value of t over here? And this will be simply as a t square. Don't put the value of t, okay? This will be t square. That is what we are supposed to find over here. Time taken to reach the ground. So can we just say it will be nothing but t is equal to nothing but 2h by g, and its a root. Square will go over here. It will come be a root. Come on, everybody is understanding, or you are getting any confusion? Am I going too fast? Should I slow down my speed? Come on. In the live chat, I need to know. Come on. Am I going fast? Okay, fine. So now we need to basically find velocity of hit, means with what velocity it will hit the ground. Before hitting the ground, what will be its velocity? Understand? So that is what we are supposed to find in this case. Use this equation clearly. That is v is equal to initial velocity is how much? That's obviously 0 because we are releasing this one. Can we say that is nothing but minus, and acceleration is nothing but this g, and time how much we got recently? That is nothing but a root of 2h by g. So this will be nothing but root of 2h by g. Fine. Now do one thing. Rationalize by g by g. Okay. So it is nothing but minus g root g into root g. G. That is 2h into root g upon root g into root g square. That will be nothing but square root will get cancelled. G cancel. So v is equal to minus root of 2gh. G. Fine. Why is this negative? Negative is basically it is going in the downward direction. That's why negative is telling you the direction of the velocity. Now the question comes over here. Find total time, time of ascent and descent to reach the h max by 2. If we are throwing this ball in upward direction, how much time it's gonna take to reach this h max and h max by 2? Understand that you need to basically find over here. Understand how much time it's gonna take to reach this h max by 2, and in completion of this journey as well, total time, time of ascent, time of descent. Can you tell me in the live chat? Come on. Come on. Just simply I would say s is equal to ut plus 1 by 2 at square in this case. Okay, it is saying that when the ball reaches h max by 2, how much time it's gonna take? So simply instead of this h, I would prefer h by 2. Okay, because it has to reach h by 2 only. Ut, we are throwing it the velocity of u, minus 1 by 2, acceleration is nothing but g t square. Okay, now we say h by 2 is nothing but this is 2 ut minus gt square upon this 2. 2 will get cancelled. So it will be h is equal to 2 ut minus gt square. Now take this over there. So this will be gt square minus 2 ut plus h is equal to 0. We got the quadratic equation. Find the roots of this quadratic equation. That's all. Now t will have two roots. Can we say that's minus b, that is 2u plus minus under root b square, that is 4u square minus 4u square, 4a, what is a? That is g. What is c? That is this h exactly, upon 2g. G. Yeah, we have the other one as well. Now in this case, what I suggest you to do is put the value of h, because this is h max by 2 and h is h max. You can put the value of h over here. That is how much? U square by 2g, u square by 2g. Yeah, so we can definitely put it over here. That is t is equal to 2u plus minus a root of 2u plus minus a root of 4u square minus 4gh, 4u square minus 4g, 4u square minus 4g into 2u square by g. Exactly. Okay, u square by 2g. It has to be u square by 2g. Sorry. 1 second. u square by 2g upon this 2g. Okay, so t will be nothing but 2u plus minus root of, see, this will get cancelled off, 2 into 2. Okay, now 4u square minus 2u square, it will be 2u square upon 2g. So t will be nothing but, take this, take this, take this u square out, it will be u only. So it will be 2u plus minus this u into root 2 upon 2g. So further you can basically do one thing, take u common and it will be 2 plus minus root 2 upon this 2g. So you got the value of this 2. Over here you can find the value of t1, you can find the value of t2. See, t1 will be nothing but, that is u into 2 t1, time of ascent means minus root 2 by g. Minus I am taking because initially you have some velocity and then it keeps on decreasing. U initial velocity minus something, that's why. And t2 you take, that is u into 2 plus root 2 by 2g. Time of ascent, time of descent, total time. So this you are supposed to do by yourself. Find the total time, time of ascent, time of descent to reach any general height. Now we have any general height, no h max by 2, nothing. Now this was the question. Okay, I'll show you one of the questions over here in this one. Next one you are supposed to do by yourself only. Okay, so this is the question I'll be showing you, and this what you are supposed to do by yourself. Because this is the easy one. Two balls are released from a height at t is equal to 0 and t is equal to t naught. The second ball is given some extra velocity, understand? So first ball is released at t is equal to 0. After some time at t is equal to t naught, the second ball is released with a velocity v naught. They will meet over here. They will meet over here at some point, understand? Why they will meet? Because this is having the extra velocity. It will cover the same distance with less time. So if I say this will cover y1 distance, this will cover y2 distance in how much amount of time? T naught minus t naught, understand? But this y1 will be equal to y2. Why? Because both will exactly meet over there. Okay, they are meeting over there. So find this equation y1, find this equation y2, equate them, you will get the answer. Okay, and that's what you are supposed to do in this one. I'll show you this one. And how many questions do we have? This, 2, 3. And then we are done. Okay, we have 3 more questions left. Then we are done absolutely. Yeah, we have 3 more questions left. Then we are done absolutely. No water, no water. Okay, let me just show you this one. Okay, so what it actually says is that, there is a balloon, okay? And in this balloon, there is a package, okay? There is a package placed in this balloon. Okay, what happens over here is, this balloon is going in the upward direction, fine. This balloon is going in the upward direction. And what happens afterwards is, it started from rest at t is equal to 0. It started from rest, and when it reaches some height, it reaches this height. Okay, it reaches this height at t is equal to t naught. It reaches this height. It's going with the acceleration a in the upward direction. Started from rest. Now, when it reaches this height, it released this package. We are supposed to find how much time this package is gonna take to reach the ground. We are supposed to find how much time is this package is gonna take to reach the ground. See the journey. First, this balloon started from rest at t is equal to 0 in the upward direction with acceleration a. At time t is equal to t naught, it released the package. At time t is equal to t naught, it released the package. So we are supposed to find from that height what will be the time in which the package will basically reach ground. That is what is the question given over here. Let's solve this question. See, we'll divide this solve question in two different parts. The first one is for balloon, we'll write the equation for balloon, we'll write the equation for package. First, we'll write the equation for balloon. Okay, we'll find the equation of a balloon, that is y1. If I say, for example, balloon has reached the height of y1, covered y1, this package will also have covered the equation, this height of y2, I would say, but y1 is equal to y2. Why? Because when they release the package, at that point of time, balloon and this package, they were attached to each other. So at that point of time, can we say that y1 is equal to y2? Understand? Because height is, they are at the same height. Okay. So find the value of y1 first. So y1 is nothing but. So can I say, for balloon, I can definitely write it, that is ut plus 1 by s is equal to ut plus half of at square. Instead of s, I'm just writing y1. So ut, initial velocity of this balloon is what? We say initial velocity of this balloon is 0 because it started from rest only, na? That's why I'm saying. So that's why I'm saying. So it started from rest, that is 0, and plus half of at square, 1 by 2 a. It is having the acceleration a, its own acceleration. I'm not writing the g over here. So it will be a, and how much time it took from this point to that point, that is t square, because t naught square, at t naught square it released the. So can I say this one? Everybody understood this one? Come on, this first equation, t naught square. Come on, in the live chat, I need to know. Now write the package, write the equation for this package, and understand, for this package. So can I say for the package it will be, now what will you put over here? Initial velocity for the package. You will say, sir, initial velocity for the package will be 0. And no, package is released when the balloon was going up. Understand? So package will have some velocity. Don't talk about when balloon started going in the upward direction, that point the package was having the initial velocity as 0. Okay, but when the package was released, that point balloon has some velocity, package has some velocity. At that point of time I am talking about, it will have initial velocity, not a 0. We are supposed to find. So use the equation from here to here only. Which one? That is v is equal to u plus at exactly. You tell me one thing. V is final velocity that we are supposed to find over here. That is final velocity when the package was released. But for the next interval, we can use this final velocity as initial velocity. For this interval, it is initial velocity. So can we say v is equal to initial velocity started from 0, 0, and this acceleration. At that point of time, what was its acceleration? That is this a, and time is what? Time is what? That is nothing but t naught. Can I say a t naught? Because in t naught amount of time, it covered this distance. So this is a t naught. So that's why it is t naught. Come on, everybody. Can we use this equation over there? Yeah. Now we need to find y2. Y2 will be nothing but ut. That is ut. U is what? This at naught. At naught into t minus 1 by 2, and take this as negative because this is falling down, and I take this as negative 1 by 2 gt square. If I say, for example, this is taking time t from falling this point to this point. Now we equate these two, they'll make a quadratic equation. So it will be nothing but y1 is equal to y2. So this will be 1 by 2. This will be 1 by 2 at naught square. At naught square is equal to nothing but at naught. If you basically interchange these, so we can definitely write it 1 by 2 gt square, 1 by 2 gt square minus at naught into t. At naught into t exactly. So if you multiply this with this one, so it will be 1 by 2 at naught square is equal to nothing but gt square minus at naught 2 at naught into t. So gt square minus 2 at naught into t minus, so this 2 and this 2 will get cancelled. Okay, so it will be plus this you keep it as it is, and it will be negative over here. So it will be negative over here. Minus of a t naught square is equal to 0. Solve this quadratic equation. This is the quadratic equation in terms of t. Get the value of t. You will get the answer over there. That is the answer exactly. Okay. So it has to be something. It has to be something like exactly. It has to be something like, it should be t is equal to a t naught by g exactly. And it will be 1 minus something like this only. You'll get 1 minus 1 root of 1 plus g by a. Yeah, something like this. You'll get the answer. Understand? Check out this. If you get the answer like this only. Now we have the next question over here on the screen. See, we are throwing a ball in upward direction and we are throwing this ball in the downward direction with a velocity 20 meter per second. Over here also with the velocity 20 meter per second. Now, the distance between these two balls is 40 meters given. At what possible points do the two balls will collide? At what possible distance the two balls will collide? That's what we are supposed to do. Use the equation for this ball, use the equation for this ball, that's all. So can we say S is equal to ut plus 1 by 2 at square? We'll use this equation definitely. So what is S for this one? For first ball I'm talking about, can I say this is X is nothing but initial velocity, that is 20t, and then you can say minus 1 by 2 gt square, 1 by 2 gt square finally. For this ball, can I say this is nothing but 40 minus x is nothing but, this will be nothing but how much? That is 20t minus 1 by 2 gt square exactly. Okay. Now add this one with this one, you will get the answer. That's all. Fine. You'll get the answer. That is 2 meter per 15 at 15 meters. Come on. Final velocity of balloon is initial velocity of packet. 1 second. See, listen to me very carefully. This is the confusing part in this one. When the balloon started going up, means it started from 0. At that point, package was also having the velocity 0. So when the balloon started going up, and over here, when the package was released after some time, at that point of time, balloon has some velocity, means balloon is attached to package, so package will also have some velocity. Understand? Now we are using equation from this point to ground. Understand? From when the package was released, means initially package was having 0 velocity, but when it was released at that point of time, it will have some velocity. What? Velocity of balloon. Understand? So how do we exactly calculate that? You use the equation, use the equation from this point to this point in this interval, that is v is equal to u plus at. Once you get the final velocity of package over here, that final velocity will become initial velocity for the next interval when the package is released. Understand now? Understood now? Come on, in the live chat. You understood this? Okay. Come on. I need to know in the live chat. Okay, sir. Got it. Thank you. Okay, welcome. Now, so this is the first equation. This is the second equation. So what I suggest you to do is you take this as plus only, because if you take from this over, we are releasing this one. Okay, it will cover this much of distance. I would say you take that negative, it will obviously become this negative also. So eventually it will come out to be this only. So in order to reduce the steps, you need to basically do this one. Okay, so basically add these two, this will cancel with this one, x with x1, and over here we'll get that is nothing but 40 is equal to, that is 20 plus 20, that is 40t. So t will come out to be 1 seconds. When t is 1 seconds, put this in this equation. So x is equal to 20 into 1 plus 1 by 2 into g. G is 10 into 1 square 5. So x will come out to be 15 meters. So x was what? From this point to this point where they are colliding exactly. I'm saying that they collided at x, from at x. If the hole is 40, so this will be 40 minus x. Understand? So this is this one. So x is at 40 meters. So at 40 meters from the ground, they collided. Okay. Now this is the last question we have, last question of this session, and then we are done with this one. Okay. It's already been 4 hours of this session. Okay. All of you must be feeling very tired now. Okay. So this is a nice question. So as asked in JEE Mains 2014, from a tower of a height h, a particle is thrown vertically upwards with a speed u. A particle, there is a tower of height h, a particle is thrown upwards with a speed u. Understand? With a speed u. Okay, fine. The time taken by the particle to reach the highest point of its path is n times from A to B. It should be A to D, exactly, A to D. Okay, I'll tell you. So the particle is basically thrown in upwards and it reaches the highest path and finally it falls on the ground. So I'll mark the points over here. If I say this is what, this is the point A, this is the point B, this is the point C, this is the point D. Okay, it is saying that the time taken by the particle from A to B will be equal to n times the time taken, the time taken by the particle from A to D will be n times the time taken by the particle from A to B. So that means time taken by the particle from A to D will be equal to time n times. This is given in the question. This is the only clue that is given in the question, will be n times the t of A, B. Understand? Time from A to D will be equal to n times the time of A to B. So call this as a T, A, B as a T. So we'll definitely call this as NT. So first of all, we'll find this T only. Then after we'll have to check. So the relation between H, U, N is, these are the 4 options. We need to find the relation between all the 3 quantities. Then we are done with the question. Let's first find the value of this T. See, you tell me one thing. Can we just say this T? How can we exactly find? Let me just tell you. So we can find this one. We can find this one. Use the equation from this point to this point, from A to B. Okay. From A to B first, we'll find this T, because this T is nothing but TAB. We call this as TAB. Okay. So can we just use the equation from this point to this point? That is V is equal to U plus AT. Final velocity at this point is 0, obviously, because when you throw the ball in upward, when it reaches the maximum height B, it's the maximum height B. Obviously, it will be 0. 0 is nothing but it will be U. Can I say this is minus, and this will be, we throw it with the velocity U at this point, okay? And this is minus G, and this is T. So can I say T is nothing but U by G, exactly. So we got the value of this T, that is U by G. Now, we need to find the relation. For that, we'll have to use the equation we'll use the equation from A to D now. Okay, we'll use the equation from A to D. So now use the equation from A to D exactly. What? S is equal to UT plus 1 by 2 AT square. Remember what I am doing, okay? This is the trick that I am using over here. So now go from A to D. So A to D, when you throw the ball from A to D, how much is the displacement? S is what? S is the displacement. How much is the displacement? Displacement is this much only. Hey, you are throwing the ball. This is the distance covered. Okay, that's fine. But how much is the displacement of the ball from the initial point? So this much. So can I say this is negative of H? If you take this as origin, this is the negative of H, 100%. So it will be negative of H is nothing but U into T. Initial velocity, I say, with the velocity U, I throw it. T is what? T is what from A to D? We said TAD. Because the journey is from A to D. So this is T to A to D. So TA to D, that is N times of TAB. That is NT. So that is nothing but N of T minus. This will be 1 by 2 G, and it will be n square t square. Till here, how many of you people understood this one? Come on, I need to know in the live chat. Come on. Siva Ganesh writing C, I don't know myself. Let's find what is the correct answer. So h minus h is equal to, this will be un. Instead of this t, what is the value of this t? This t is nothing but t of ab. So t of ab we got already, this from a to b, t, that is u by g. This is the trick, understand? These are the loopholes that I am using. U by g exactly minus 1 by 2, and it will be over here n square u square by g square. Instead of this t, I am putting u square by g square. Scene kya? So what else? So this will be h is equal to now u square n by g minus 1 by 2. 1 by 2, it will be g square into n square u square. Okay, fine. Everybody clear till here? I want to know in the live chat. I want to know in the live chat, all of you. These are the last steps we are doing over here, then we got done with this one. Okay, fine. Okay, everybody. Okay, this, oh, there has to be this g also, this g. Okay, so this g and this square will get cancelled off. So can I just write h is equal to u square n by g minus, it will be n square u square by 2g. So further simplification, so a minus h will be nothing but, so multiply this with this one, 2g u square n minus this, it will be g n square u square upon this 2g square. Now this square, this g we can cancel out over here. So it will be, is there any more space? Yeah, we have. So this will be minus h is equal to, minus h is equal to u square n square, 2u square n square, 2u square n, not n square, 2u square n, 2u square n, 2u square n minus n square u square minus n square u square upon 2g. Is it correct? I hope the answer is gonna come. Okay, so this is minus 2hg. 2hg is equal to nothing but 2u square n minus, it'll be nothing but n square u square exactly. Okay, let's have a look on the options first, then accordingly we'll see. Square n square u square. Okay, if we interchange this, so this will be hg is nothing but n square u square minus 2 u square into n. Okay, into 2u square into n. Is there any chance that we should go with this one? Come on, I need to know in the live chat. Are we doing it correctly? 2hg exactly, n square into u square, n square u square, n minus 2, n minus 2, n minus 2, n minus 2. Yeah, we got the answer exactly. So can I just write 2hg is equal to n u square, take n square n. So what we are supposed to take common, nu square. Okay, fine, nu square. So it will be nothing but over here n minus 2. So if you take u square common, n common, so it will be n minus, and it will be obviously over here, that will be 2. Is the option matching now? Yeah, 2gh is equal to n square u square, nu square into n minus 2, nu square into n minus 2. Option C is the correct option. No, option C is the correct option. Okay. Yeah, finally. It is already 10:10, okay? So you are with me from past 4 hours and 10 minutes. It's great. Okay, I got it. I got it, man. Okay, so shall I go now? Shall I go now? Everybody go to sleep now. Take a chill pill. Let's see what happens tomorrow. Okay, okay. Too tired now. Finally. Okay. So, ladies and gentlemen, thank you so much. It was nice interacting with you. It was really nice interacting with you. Yeah. Bye, Ria. Bye, Kushi. And I need to tell you, you can definitely join our special classes if you download the Unacademy app. Thank you, Kushi. Means a lot. Seriously. Okay. So, you can download the Unacademy app and enroll over there and sign up and log in with your mobile number. And then you can find me over there, search my name, Yawar Manzoor. And this will be the interface you can get over there. Click all the special classes. If you enter any of my special class, it will ask you for a code, use Yawar. And these are the batches we have launched recently on Unacademy. So definitely you should join these batches in order to boost your rank in your upcoming JEE Mains and Advanced 2023. So definitely you should go for this one. And this is the Shine batch for class 12th and Mains and Advanced 2023. You should definitely go for this one. And apart from this, we have, that is the Unacademy's own platform. Apart from this YouTube platform, we have Unacademy's own platform. Over there, you can take the Plus subscription and Iconic subscription. In this Plus subscription, you will be getting live classes, weekly tests, structured courses, unlimited access. And in this Iconic subscription, you'll be getting personal guidance, test analysis, experts guidelines, study material, study planners. Basically, you'll be getting all the features you get in Plus, and these are some extra benefits that you get over there. And you can definitely follow me on Unacademy. This is my username, Yawar Manzoor. You can take this Plus subscription for 3 months, 6 months, 12 months, 18 months, and 24 months. EMI options are available as well. You can definitely go for that. Okay. And by using my code Yawar, you can definitely get the maximum possible discount. And if you take this Iconic subscription for 12 months, 18 months, and 24 months, you can definitely get the maximum possible discount. This is my name, Yawar Manzoor. This is my name. This is my code. You can use this one. And this is the price. And this is the IIT JEE Mega Combat Scholarship Test. You can go for this every single Sunday. Yeah, let's see. Okay, you'll get the notification. Don't worry about that. Chill. Okay. And this is, you can win up to 4 crore plus scholarship. It will be on 22 of August. It will be next on 29 of August and 11 a.m. 20 questions, 60 minutes. There will be, if you get the rank from 1 to 3, you will be getting 1 year of IIT JEE Plus subscription. Okay. And there are other benefits also that you're going to get. These are some of the benefits from Amazon as well. And if you find any of my content as inappropriate, there is a link in the description. You can definitely report over there. And ladies and gentlemen, thank you so much. It was nice interacting with you. Subscribe to this channel, JEE English Unacademy. Hit the bell notification and like and subscribe as soon as possible. Okay. And thank you so much. It was nice interacting with you. Take a chill pill. Bye. I need to go now. Thank you. Bye-bye. Take care.